thanks a lot to our hosts for having us here. So the idea, this is a first workshop on ELIAS project, and we consider it to be a showcase of the things that we are doing in ELIAS. And you will see several aspects. So we have several sessions related to sustainability. And one goal is to kind of be able to define what sustainability is. Okay, so we know it's a big word. We know it's a buzzword now. Everybody wants to use sustainability. Everybody thinks that, yes, indeed, we need to consider sustainable solution, whatever this means. And we consider in the project to have sustainability at different levels. So this was in the design of the project. So we consider to have sustainability at the planetary level. So this means, you saw also yesterday, material science, vegetation monitoring, all the climate changing and all these type of things that are related to, let's say, the planetary level. Then we have the social part, so sustainability at the level of the society. So how we as a community or we as communities are impacting now the planet and the individuals. And then the third level is the individual level, in which we as individuals are having impact on the planet, society, and then or ourselves. So these are, let's say, the kind of scientific part. So that will be the presentations related to the first sessions. Then what we are doing in the project, sustainability is also important at the level of people. So you guys are the ones that are imposing and are going to promote this sustainability, but also we want, through the measures we have and through collaboration with ELIAS, to make sure that we are attracting in Europe in general the best talents, and we are keeping the best talents in Europe. And this is something that you will see in a later session. And finally, another thing that is important for sustainability, and you will see presentation on this, is the sustainability at the level of, let's say, small companies. So also the young people should get the education and should get the incentive to open up startups, and through this to make sure that we are promoting research and we are moving forward into this direction. So I think these are all the aspects that are of importance to ELIAS and also are of importance to a broader range of, let's say, of audiences. Before everything, so let's say last but not least, we have also things that, and this is will be the keynote of Professor Marko Milosavljević. It's on ethics, right? So, and you see, we have a title which is related to, let's say, sustainability. So power without responsibility. So power, yes. So we do have, when we talk about power, but also the ethical aspects, which are quite important. And Marko will give us some ideas about, indeed, we do have, and in Europe, we are known for making regulation, but how this regulation can be used to our benefit rather than just be a burden. So Marko, please. Thank you.
I wanted to tell you and the people online that this meeting is being recorded.
Yes.
So.
There is no remote for this to move the slide. No, oh, okay. I'll try to stick with this. This is nice. Okay, it works. Okay. Thank you, because I'm aware that this is the morning and you're still waking up from the nice dinner yesterday evening, not those of you over there on Zoom. That's why I'm standing up, because otherwise you will surely fall asleep. And that's why I'm using microphone, because I know that it can very quickly be a problem also for people in the hall if the sound is not that clear and so on, not just for people online. So first, let me thank to Nico and Cecilia for inviting me and the whole ELIAS team. This is the first time I'm here at your meeting physically. As you know, from the last year, I've been invited to help and participate with some of the ethical concerns and also ethical reports about what you're doing here. Just a brief sentence. I'm a professor of media regulation and policy and head of communication department at the University of Ljubljana. I'm involved or was involved with a number of regulatory and recommendations documents from Council of Europe and European Commission, as well as national law right now in Slovenia, which is also the law on media, but it also attempts to regulate the artificial intelligence used by the media not just in journalism, but also in advertising and creation of content, such as videos and other things. So I will start with my presentation, if it moves. And it doesn't. Anybody has any idea before we could move it, but now we cannot move it?
Stop sharing. Okay.
This?
Okay.
Okay, so I can do now. Okay, thank you. I will be talking about some of the concerns about the artificial intelligence. And of course, these are concerns also related to individual countries within the European Union, but also to the European Union as such, European Commission. There are a few main aspects that are considering the artificial intelligence. They're called ethical, legal, and societal aspect. This is actually the official acronym. So your acronym. So we are in a way connected with all of these three aspects. And just for your information, this is a background picture from The Economist, the magazine about the AI. And it shows that what it's trying to represent is that AI can be also a saint, like an angel, but it can also be a devil in a sense of causing havoc and problems in the society, which is something that also Mr. Harada, very well-known author and, let's say, essayist and philosopher, agrees about the problem of the human existence in a way, and the way it's changing. So that is the main reason why AI is being increasingly discussed at the level of regulation and at the level of ethics. The title of Power Without Responsibility is actually taken from the media aspect. It is a well-known claim from British Prime Minister back in 50s that media and journalism has power without responsibility. That they have a lot of power, but they otherwise don't have much of responsibility. Journalists very rarely resign. They cannot be sacked in the sense of elections and so on. And now this has been a well-known thing. And just recently, like a month ago, a book with this title has been published, again, about the question how the media should have responsibility. But we can talk now these days about perhaps even a more important issue, and that is the AI very often has, and creators of AI have power, yet it is unclear how much responsibility currently they do have. So we're looking at the main areas of the AI implementation in the terms of society. So not in terms of research and methodology, we'll probably talk about this a little bit later. Why the society is so concerned about this. First, of course, is the issue of jobs and unemployment. It can sound very petty, it can sound very small, but on the other side, these are some of the actually main economic and societal issues about the implementation of AI at a number of levels later. There is also, of course, the question of responsibility and accountability, this sort of power without responsibility. There is also, of course, question of human rights in all sort of aspects, whether it is privacy, surveillance, any sort of potential abuse. And of course, there is generally the problem of abuse at any of these levels. So because of all these aspects, what we have to look at, and also this project, is we always have to look at the worst scenario. We can always say, and this was also last year, we talked about the ethical potential problems, and it was like, no, we don't have that. And then we talked a little bit more, and suddenly it was like, oh, okay. We always have to look at worst case scenarios. It's not what you want to do with it, but it's what if somebody else will use this data, will use this equipment, will use these tools for any sort of worst case possible use, and I will talk about it a little later. So we have to be something like devil's advocate, meaning that we ourselves have to look at this worst case and looking at any possible potential for abuse, and of course, trying to prevent it or limit it, or simply being aware and warning about any sort of, let's say, devil's use and abuse of the AI that might start from there. As I was speaking about the jobs and unemployment and so on, these are some of the first concerns from the AI discussions. You're probably familiar with Mr. Norman Wiener from MIT. He was writing about that already in 1940s in his work, The Human Use of Human Beings. And he was talking about what if all this automation and artificial intelligence will be used without proper regulation, accountability, responsibility, and so on. And he says that it could lead to the massive unemployment, compared to which one the depression in 1930s and 20s will seem like a joke. So we are seeing that today, but it's not just from Mr. Wiener, famous writer, and I misspelled it over there, but here it's correctly spelled, Mr. Kurt Vonnegut. Already also in late 40s wrote a story called Piano Player, where he sort of forecasted a number of these issues that we are actually facing today. So what if the society is run by a few technological barons who are only oriented at profit and, of course, increasing their profit, and they don't care about society? And on the other hand, we have automation of all possible jobs, again, leading massive, not just unemployment, but also people losing the sense of their lives and their purpose in their lives, because job is not just money making, it is also sort of creating interest and purpose for many people to do it. And you yourself are aware, because your research and your educational work and other work is sort of driving you. Otherwise, you would perhaps be already now, perhaps it will be in the future, but you would already be at some other company, more privately, more oriented, more profit-driven, less concerned with ethics and society and so on. And so this is a real problem right now. This is an assessment by Goldman Sachs saying that 300 million jobs may be lost very quickly to artificial intelligence in the future. In addition to that, there are real concerns, I'm just using very recent writings and so on, from movie production, from questions about copyright, as well as, of course, as you're all aware, about the sort of attempts by Mr. Musk to cut as many work and employees also at the level of the, not just government, but also all the private companies that do work with the US government. There are other issues as well, of course, such as privacy, surveillance, and other things. You probably heard about the DeepSeek's problem with whenever you try to find anything about Tiananmen. So there are very quickly concerns about that. There are problems with the use. This was a recent UK case where they decided to stop certain projects involving AI and in terms of social benefits. Perhaps, is there anybody from Netherlands? No? Yes. So you're probably familiar with the case of a few years ago when there was this huge scandal in the Netherlands with the mistakes done by AI in terms of social benefits. I think that a lot of people actually not just lost the benefits and so on, but some of them even committed suicide. So that is a major concern about the simply mistakes within this and the cause and problems that it can cause, but also the use in other ways, simply by saying that how that the sound of your voice can show whether you are ill and things like that. The analysis of voice, for example, is also being used in some AI, for example, to identify gay people by the way they speak. Which can sound, okay, well, weird, interesting, funny, whatever you want to call it, but it's not funny if you're in many places in Africa, many places in Asia, where homosexuality is punished by death. So any sort of such use of AI can have also other consequences and repercussions. There are also other questions of transparency. Here is a dialogue with CEO from Facebook saying basically that they found out that basically what they want to give people is as much of what they already want. So it's again a question, what do you actually give with the algorithm and with the development of things, giving the people more of what they already want can lead to many other things, such as topics such as echo chambers and so on. But also you can see also other problems, such as why is, or they are, I wouldn't say mistakes necessarily, but why does these lead to some sort of changes in the translations or many other uses? New developments, very difficult to follow. All of these are just screenshots from stories from like a week or two ago. And of course, there is also a question about new developments, as I've said, not just in terms of new small developments, but also larger ones, such as Manhattan Project for the AI. So returning back to our aspects and so on, the regulation is slowly being developed. As you're familiar with, the European Act on Artificial Intelligence has been adopted, but it's a very general act. It doesn't go into specific issues, just discussing aspect of copyright, which is now a topic of many court cases of media companies and other companies suing AI developers for using their data, but also actors, musicians, and so on, also suing or wanting to protect their work, their voices, their images, their music, their lyrics, and so on. So it's mostly it's concerned with questions like security issues, terrorism, and so on, which your work, of course, is not related to directly. We would only need to see whether there is any potential that this could be used in also some other ways, but also the sort of general framework that is difficult to follow all the current developments. There are also questions about recommendations from Council of Europe, which has now released a couple of these recommendations related in ways also to AI. It is not obligatory, it is not binding, but it simply gives the stakeholders, including states and so on, some potential to develop certain more obligatory framework. Then we are working also on the European project Diacomet. Right now, why I'm mentioning is we have just these past months analyzed more than 400 of different European codes of ethics, including scientific, political, PR, journalistic, companies, banks, and so on, looking for what they say about AI. And not just that the laws have mostly not been adapted to the AI, it is also the case that most of these codes of ethics, even though they are adopted by scientists, journalists, politicians, and so on, which means they can be adopted much quicker, all these years after the development of AI, more than 90% of them don't have any mention of artificial intelligence and don't sort of define anything or any reasons of ethics and concern within that. There are further reasons for concern. Google has dropped pledge not to use AI for the development of weapons or surveillance. So the policies of certain companies are changing. That shows the limits of self-regulation, the limits of when a company says something and saying that it will not do something. And that's my reason why I believe that certain level of official regulation needs to be adopted. But then, of course, there is a question of boundaries. What needs regulation and what doesn't need a regulation? The questions of abuse of existing things, like the fact that Elon Musk's connections to SpaceLink are used by different themes of money laundering, of drugs or other abuse, and so on. So any of these sort of very well protected communication or other anonymous sources can be used also for illegal activities. This is a story from Financial Times, like 10 days ago, that European Union has actually decided to decrease actually some of its intentions about the AI regulation. Officially, it is because it wants to sort of foster the development of AI within the EU, something that Nico was also mentioning, the importance for European Union and European Commission to enable environment also in Europe that it is open, that it is economically open, but it is also open in terms of not being too rigid and not being too bureaucratic and so on. And then, of course, it's a problem of finding the right boundary. There will be a discussion at the Paris AI Action Summit, and there are four main areas which they will affect. One is about human and planet welfare, human rights, equality, and sustainability, direct areas of what you are doing. But there is also related to accountability and transparency, particularly explainability and responsible decision making, including AI governance, particularly concerned with bias, which can be a huge problem for ethical and societal aspect of AI, as we also saw from some of the slides. And of course, the question of a specific regulation, also sort of anticipating what can happen within the AI, and of course, then developing, fostering appropriate regulation. Just as a sort of interesting sort of aspect, the British government has now asked and engaged a number of science fiction writers to write stories about the potential development of humanity over the next few years and decades. They want them to develop their imagination and to develop stories what can happen. So this is officially done by British government, British Ministry of Defense, Security, and so on agencies, simply to see all sort of, like we said, worst case scenarios that we said, okay, all the things that can happen, and we perhaps don't foresee it right now. Because we have seen that in the past, as you perhaps know, in 1950s, already 1940s, as soon as the development of atomic bomb, but also Cold War happened, US government, but also other governments in the East, not just engaged scientific fiction writers, but also quite surveilled them quite a lot when their stories were too close to reality, or perhaps announcing in a way something that they were quietly developing. And nobody knew that, but science fiction writers were sort of imagining what can happen, and actually it was very close to the truth. And that is the same thing as with many analysis and forecasting of AI today. So that's why also this sort of development of things that can happen in the AI are important. So my final thought here, and before we start this Q&A for the session, is that we can talk about potential areas where you can see any sort of potential ethics concerns within your part of the project. Usually when people are asked about ethics, they only look at the methodological aspect, such as gathering the data, GDPR, informed consent, where do they keep the data and so it's safely stored somewhere, and these sort of things. And then they think, oh, I'm not working with minors, with children, so it's fine. And then they think, I don't work directly with security, terrorism, so it's all fine and so on. Yes, but as we've seen already last year, a number of these things can be also sometimes seen as potentially ethically problematic, or it's good that we sort of notify the reviewers and European Commission what we are doing. We cannot simply say there is no problem, we're following the GDPR, we're following safety measures regarding data. As soon as you have AI, even if you say it's sustainability, even if you say it's about housing, it's about this and that, you're probably all aware that the questions such as the Internet of Things and connectedness of the appliances at home and so on, they can pose a lot of issues, not just about privacy, but also, of course, about potential threats. Anything that you today develop within your car and the computer in your car, computers in your fridge, computers in your anywhere actually, can pose not just a privacy issue, but it can pose also a safety issue. You have perhaps seen the action by Israeli Secret Service when they were using pagers. So they exploded with the Hamas and some other, I don't know, leaders and so or soldiers or whoever. So any of these technologies, any of these gadgets, appliances, and so on, when used with the algorithms, with AI, with any sort of internet connectedness, can be potentially used also as the danger to safety or to the sort of well-being or so on of people. And that includes also other aspects, as I said, such as homes, sustainability in terms of heating, sustainability, this, what and how all these things can be done. So if there are any concerns, I will also stay here for a few more hours. And what I propose is also, I will sit somewhere over back, and I don't want to interrupt later colleagues. But what I propose is if your team has any concerns or any dilemmas that you think you would like to chat over with me, not just via Zoom later and so on, it's much easier. We can simply walk outside, have a seat, and talk for a few minutes to discuss this. And it's also easier for me later to write a report, but also for you to know where you are and how you are. And also, of course, now we have some hopefully still time for Q&A.
Okay, thanks a lot. So my name is now advisor, probably I should have said at the beginning, but here that was kindly now. We also wanted to come and meet us in person and see exactly what are the concerns that we have in the program. It's a good approach. Right.
So thank you very much for the talk. One question, so basically trying to pick your knowledge because you have been very useful to us complementary perspective on issues. Europe is very good at having regulations. There are some regulations that we have to be protected, like the shall not put bad advertisement in front of children or these kind of things. And we clearly see that at the world scale, there is a significant push trying to, let's say, intimidate European institutions into weakening or abandoning their regulations. What is your bet, if you have any bet? Like, how do you see these things? I mean, I have a former PhD who works at Microsoft now, and he was saying, European GDPR is great. They get that work for several years to adapt our products to European GDPR. Okay, so I think some of the companies, they can operate within European regulations, and that's still a way to do business. Yeah. But clearly, right now, we haven't against many of these things that some Europeans have been signed up with. Yeah. So how do you view the future?
In a way, on one hand, this is a return back to the 1990s, when everybody claimed that internet should be completely free. There are no rules and no laws, especially no national laws in the internet, so it should all be free. And it actually showed up not to be so free. And there were very quickly problems with copyright. There were problems with, of course, children. There were problems with terrorism, as we saw after 2001, and so on and so on. So that quickly folded down. And then the European Union also became very concerned. Why? Because social media and also other platforms such as YouTube and so on were suddenly here, and they had no real laws. They had no real regulation. Everything was left to them. But as we all can see also otherwise, an owner between a sort of self-regulation, a sort of being ethical, and increase of profit will always basically choose increase of profit. If you ask leaders in Silicon Valley and so on, you will see they don't allow their kids smartphones, they don't allow them tablets, they don't allow them YouTube, they don't allow them apps, they don't allow them games. So then I'm wondering if this is so harmless as they claim sometimes, why do they do it sort of differently? I mean, I would even be concerned that even if they would allow them, but it's very clear and very public that they don't allow them. So European Union has decided for some of these regulations. We sometimes see that some of the aspects of GDPR can be a little bit an obstacle. We are sometimes sort of tired of all the clicks and all of these other things. Yet the other hand, the other side is dangerous. And I can also say that whenever somebody comes and say there should be absolute freedom of internet and absolute freedom of speech, it's like, no. It's not happening. It's not happening right now. It's not happening even on their own platforms. Just try to post a picture of a topless woman on Instagram, Facebook, or X.
Yeah,
And so it doesn't work. It doesn't work when it comes to terrorism. It doesn't work when it comes to so many topics. And it's good that it doesn't work because there's also protection of children and abuse and pedophiles and so on. So no, that should not work. Of course, there's a question, where is the boundary? Where is the limit? That is always. But sort of this sort of claims of we don't need any regulation. No, it just doesn't work. So I hope that European Union, European Commission will insist on some of that. I hope also that it will have discussions with all the stakeholders in order to enable development of things in Europe, not to burden them, not to limit them too much. But yet, on the other side, we are all aware how quickly things can be abused. So that's why this worst case scenario. Sorry, I was interrupting your thought.
No, I would say that, for touching, are becoming a lot more in terms of, people,
What?
most of them.
Yeah.
Following the.
Yes.
Yeah. What they consider as.
Sounds like it's like on Facebook, criticizing us, and it was rejected.
Yes.
That's the.
So now we're checking, not checking when is the right moment. I would see some of the things that probably is little bit later, we talk a little bit about safety. So also when we are building our network, we are also trying to build this safety by design in our network. When we will talk about okay, let's take a map again. So and there is a small change in program because Stanislavski is not here, he had some problem last week. So now Marius has asked for a little bit more time. They had some great news about the new Romanian hub, AI hub that has just been approved. So this morning.
down infrastructures and also people.
Okay, so I hope it's okay now. Is it?
Yeah, we can hear you
Yes,
now.
so this should have been solved from the start. Can you hear me?
Yeah, we can hear you, but we don't see any slides yet. Now we see the
I don't
PowerPoint in, but not in full screen mode.
It's not in full screen mode?
It's not in full
It is,
screen.
but it's kind of slow. It will take a bit of time.
Okay. So patience is always good. I'm happy. Thank you. Okay, so today I'll talk about a part of our work which I didn't mention yesterday, which has to do with our work on ELIAS at the planetary level, sustainable AI at the planetary level. And it's about bringing consensus among several ways of seeing the world, multiple views, multiple tasks. So it's related to multitask learning. Also, it's related to unsupervised or self-supervised learning. The question is how we can put all this together to reach a consensus and use that consensus as the pushing force towards learning. Can consensus be our ground truth in some sense? And how are we going to do that? Because we see consensus, so this is an observation. The more I think about it, the more I realize how general it is. Consensus, from the moment I start moving, if I move in a certain way, I see the image changing in a certain way. The geometry of the scene is in a certain way. The two are linked. There is a perfect consensus there, and actually we have a mathematical formula for that, which nicely brings robotics and vision together. But then consensus is also at higher levels between things look, what things are. If I see children playing on a soccer field, the way it looks, the way it is, then at a certain semantic level, I say, okay, they are playing a soccer field. After I watch that for some time, I see the rules. I decide there is this game. Geometry related to semantic segmentation, related to what's taking place in space and time. Actions, 3D, semantics, optical flow, everything. So how do we put them together?
It's not sharing.
No?
Let's try to stop again and do it again.
That's exactly what I did.
You have many of these screens, and so
Yeah, but this is the one.
are you
Okay.
sure?
Yep. That's the one.
Is it?
It's not sure.
Piece of the presentation, but not the presentation mode.
This is in presentation mode. No, it's not in presentation mode anymore. So could you see it at the beginning, but you didn't see, you didn't hear the sound?
The slides didn't.
The size of it.
Now it should be fine.
Oh, can I move them a little bit?
It's moving.
See, it's unfortunate when the physical meetings are interrupted because of the.
You can do it now.
Truly, we should fix this as engineers, I think, because it's not the first time that I'm facing this kind of difficulties. Okay, so can you see that? No? Okay, so let's make a decision.
Now go ahead and do it. This is very important.
No?
Yeah, go ahead.
No. The question is the following. I will try to solve this issue. At the beginning, at the start of this, you could see the slides moving, or so my voice was off. Do I start the video?
No, the slides just didn't move. It was only stuck.
But go ahead, Marius.
Yeah.
Go ahead with your presentation.
So how did it know to show the first slide?
Go ahead with
Okay, now it's-
Now we can see.
It's working. Okay. Yes, so this idea started with an initial paper in 2021, but then we developed up to the current moment. So that's why I'm introducing this, just to get a better understanding. And maybe people are not, everybody's familiar with this idea. So the first idea we had is to have different views of the world and connecting them. And how can we connect them? Of course, we can connect them in many ways. We'll talk about that. But one simple idea, straightforward idea, is let's connect them through neural nets. So that basically from one view, we can predict them. Okay. So basically, in order to predict depth, I could go from RGB directly, or I could go from RGB to semantic segmentation, then to depth, or I could go from RGB to normal surface to depth. So I can reach one representation from many pathways, depending on my graph structure. Now, reaching from many pathways, if I want consensus, what do I want? I want them to be in agreement, or basically I'm automatically getting for free an ensemble. And I'm getting an ensemble at every node. And how do I put this together to get the consensus? So I could learn ensembles, or I could just make the average, or voting, or other ways. But the idea is that this graph, multitask graph, already gives me a multi-ensemble system that you could imagine how you could self-learn, basically, because you get all the answers, then one of them can learn from the consensus of the others, and you can keep going. So at least conceptually, you can do that. Now, you can also show theoretically that under certain mild conditions, this gives you stability and convergence, which we noticed in experiments as well. Now, of course, our experiments, what they show, and this is really nice, is that after a few iterations of learning, self-learning, and by bringing new unlabeled data, you improve, which is what we want. But then another thing we observed, which is actually something that makes me happier than the accuracy, is the stability. What this graph doesn't have is the temporal component. And what a lot of state-of-the-art methods don't have is they don't have this stability over time, especially if they're trained on images. But what we see after this consensus is obtained is, I should show from the beginning so I could explain what we see here. Here is after consensus, whatever representation, and before consensus. And it's not only the accuracy per frame, but the stability. You can see consistency, which we have. You know, if something is a rabbit, regardless of which way I look at it. But state-of-the-art methods today don't have it, just like that, even though they are state-of-the-art, which indicates that they are doing overfitting, that there is something missing. They have features that are not invariant to viewpoint changes, which we get here. And this is what I truly like, because we have observed this. So consistency in time should also be measured, not just accuracy. thing. And then, of course, this is related. I remember when my father told me a long time ago, he's a doctor, so he told me about this homeostasis, which he was very fascinated about. And I think it's related to that. It's the innate tendency of living organisms towards a relative stable equilibrium between their in the interdependent elements. And we see this at all levels in the intelligent systems, in living systems, the planetary level. And at some point, we'll have to say this more explicitly and probably use this for sustainable society, sustainable AI. Even if we look at the basic, maybe the first brain made of, not brain, mind, or nervous system made of several neurons, Hydra, if you're familiar with it, it's probably the first one that we know about, in which several neurons doing multiple tasks, they communicate information until they come back, forming a full circle, and find consensus in order for these multiple neurons to move the Hydra in a unique unitary way. Because if all these neurons will pull the Hydra in different ways, you will not get anything reasonable. So they have to work as a unity. And that's an example, one of the first examples when the mind is formed from multiple elements. Now, we live in a connected world. We all say that, we all know that. How do we represent that? How do we formally think about that? So I think this could be a direction to go, to think of this consensus as our ground truth, because what is ground truth, right? We don't have access to truth. So maybe multi-view, multitask consensus could lead to a self-regulated, self-supervised way to achieve sustainability. And we moved with this idea, because the graph is just one way of trying to do that, a simple way with pairwise connections. What is the structure of the graph? So the next paper, which we had with Elena and Emanuela during their PhD work was okay, let's connect this graph in a let's make this graph fully connected. And it works even better the more connected the graph it is, which you kind of expect because you have multiple ways now, even more ways being formed, but you do have a problem. Immediately you realize, because having so many neural nets, you have to take care of all of them separately, put them together. This is becoming extremely expensive. Basically here we have about 150 nets or something like that, 144. And imagine which network you have to take care of it. So this is not, you cannot, it doesn't scale well. So you have to do something about it. But we did observe from a qualitative point of view, it's all good. It's just that we cannot move further without doing something else. So you see this consistency improved, you see this performance being improved. And now let's move to the real world. And I was always passionate about flying. I didn't become a pilot of planes, but I became a pilot of drones. And I just realized I had this project, Space-Time Vision, with drones with Norway, and we had to buy drones, and I started flying drones. And then I said, okay, let's get this very nice data set, which is not, there are still not a lot of available data sets using drones in the vision literature. And let's do research in that direction. And we were very happy when we got this best paper award, the first UAV workshop in computer science. So after time, I like also to go to different nice places in Romania, and not just Romania, but because Romania is right here, it's a beautiful place that needs to be discovered. I went in different places and I recorded, and I got this very interesting data set, very varied, different types of scenes in nature or in urban or rural, mainly in the sea. And we also got some data from Norway. And we said, okay, so we published this data set with the research, and we said what we can do with it. And even to this day, as it grows, we keep growing this data set. It is the largest data set with segmentation available, depth, and everything that's available in the computer vision community for drones. So we are still at the beginning in research, even though we think we are advanced. Magic happens, but it's still at the beginning. So initially we had this paper in which we showed how you can actually automatize the process of labeling and semantic segmentation from just very few frames being labeled by hand. and we propagate through the video. We also have a mathematical formulation that shows that actually this converges with eigenvector. Again, a Spectre solution. I really like Spectre solution. That's coming from my PhD when I worked a lot with graphs. So I'm kind of at this point almost like designed to work with graphs. And you can see the stability and everything in the paper. It's getting attention, but not sufficient, because it is the best way to propagate labels in video up to this date. Okay, so we have propagated, so now it's fully labeled. The data set we checked, it's over 95% accuracy, this labeling, this automatic labeling, which is really nice. And we can move on now. So we said, okay, so let's try to put everything together. This is in Slanik, Moldova, the drone flies, let's reconstruct the scene, let's do everything. Let's see what we can do with the drone. And then at ICCV 2023, we had a different paper in which we said, okay, maybe the graph is not enough. Let's try to build a hypergraph. Meaning what? Meaning that why should I predict one representation from a single other representation? So why should I limit myself to pairs, to pairwise connections, to edges? How about hyper edges? When n-1 representations can produce the nth representation. Is it more powerful? Indeed, it was more powerful. We showed that actually the hyper edges are much more powerful than even groups of edges. So now you have these possibilities, but the problem is, of course, it's even bigger now. How many hyper edges are in the graph? Much more than edges, right? You can immediately see that it's combinatorial. Then it's getting more complicated. And again, we had neural nets specialized for different hyper edges and the way we build them. What is the structure of the graph? Do you do it by hand? How do you learn it? So you get into bigger problems from a practical point of view. So this is the main limitation. But you will see that we do have an approach to solve that, and I'll show you. So this is some technical parts which you can actually read in the paper. We have improvements over the previous graph-based method. And here we compare with the state of the art. This was state of the art at that time, master former. Maybe you know it, maybe you played with it. It's flickering like that. And this is our method, which is stable. And this is the human, which is maybe not as stable, because humans don't necessarily agree with themselves or with others, but it's still stable from a human perspective. This is not state of the art, okay? And you can see that in all scenes. This is, and this is also a good opportunity to discover nice places in Europe and in Romania. And we do have, Romania is very lucky because it does have everything from the sea, delta, mountains, everything. So, and it's everything close to Bucharest, by the way, like 2-3 hours. Okay, this is also, this from Norway. Now, the Norway video is interesting because the classes are different. You have this oil rig, which you didn't have in the other data set. You have, which you didn't have in the other data set. So this is a possibility, dear Nico, to do some category discovery here. And this could be some nice future work because you always have new categories showing up. In this case, they were labeled as little structures, cars, in our case, and these are tall buildings, which makes sense. Okay. And then you can use this at the planetary level. So we have a paper on the planetary level. We took data from NASA satellites, but we also take from ESA satellites. And it's the same idea. The Earth system, it's an Earth system. They actually have a name for it. It's a consensual system between different layers, between different representations. And if the case of living organisms, we have this name homeostasis. Here we have the Holocene period, starts with an H. Again, it's holistic, right? Representing the last 10,000 years since our civilization has truly, flourished. And it's stable. It's related to that stability. The temperature fluctuated in the last 10,000 years, only 1 degree in average per year, which is nice up to this point. We don't know what's going to happen. Hopefully, we will keep this under control, because now actually you see that the Earth is not as stable anymore. It's trying to it's going beyond this 1 degree. But this is basically consensus, right? And it's consensus between many layers. And if you look at the NASA website, you'll see how many layers they have. They have many layers. Life, biology, vapors, water, fire, everything you want. Now, how are we going to put this together? And I should have said this yesterday in the co-creation part, but I wanted to leave it for today. How can we put all this information together? What computers do we need? What approach do we need? What views do we need? What perspective as humans to put this together to actually understand this system, which is a huge system, and a lot of learning should be put there also, not just climate scientists, but also what are we going to do? What is the model? What is the foundation model for this? So we have this paper in ICCB 2023 which is basically the same idea but applied to Earth. And these were the layers we used, about 19, 20 layers. So a lot of times people call multitask learning, they are limiting themselves to 2 tasks, and they call it multitask, or 3 tasks, 4 tasks. Not that many papers use many layers when they call multitask. And this multitask, we should use as many as possible. And the nice thing for the research, but the not so nice thing is that a lot of data is missing. So you can use this graph to actually fill in the gaps, work with missing data, recover missing data. What we observed, for example, what's interesting is that we try to predict in the future, and our prediction in the future was degrading slowly, which is showing the planet is changing, basically. Because if the distribution was identical, there was no reason why you have this increase in error. Now, is this significant? Is this a coincidence? I don't think so. And then also after iterations of learning, you have better predictions at the 3rd iteration than at the 2nd iteration. Okay. The same thing we see here. You cannot you cannot see with the naked eye the differences. Is the green is better than red? The green is more than red, which is good. The more you have green, the better for the learning. Okay. And then we move on to the next level idea, which was I was trying to think a lot how we can make this graph more efficient, or hypergraph more efficient. And I think I got the idea, at least the initial. This is current work. It's not published yet. We'll publish it very, very soon. We need to, because otherwise we lose it. So how about I have this hyperform, whatever model I put here, with whatever layers I have here. Some layers could be produced even by generative models or analytical solutions that could connect them. It doesn't matter. We'll put everything. And then whatever you have available gets into this model and comes back with an answer for all of them. This is also, this starts to be related to this masking of autoencoders, because mass autoencoders, and I always believe that there is a relation to this and mask autoencoders, actually cancel some part of the input image and recover it from the contextual input image. How about if we do that for entire layers or partial layers, but we have many layers? It's the same thing. Then our graph could be modeled by a mass autoencoder, multi-view mass autoencoder. Our ensemble, our hyperedges are nothing but a specific type of masking, a specific way of masking. By masking certain parts, I basically call those inputs, and the ones I get out are the outputs. And hyperedges these are the hyperedges, and ensembles are just multiple random masking from some distribution, which we have to think about what that distribution would be, because that distribution of masking is actually my distribution of hyperedges. So even though I don't have access to all hyperedges, I could have access to their distribution, and I could sample from them, and then automatically I'm getting my ensemble, and at the end I put everything together. So this is how this vision looks like, how the hypergraph is actually equivalent to this big hyperformer, and this theoretical part, which is good for inspiration, for concept, and for understanding what's going on. But then you have to implement it, of course. And we did that. And this is work with my student, Mihai Purvu, who hopefully will graduate this year and will present it as part of his main thing in the thesis. So these are the different views that we can create. Analytical, not analytical, it doesn't matter. Let's use everything we have, and as much as we can in an unsupervised way, automatic way. And what we noticed. So here is what I noticed again, which is really interesting. These are two state-of-the-art models or recent models. And this is after we implemented this with the autoencoder. This is the state-of-the-art model. This is autoencoder samples, and this is after distillation. You can see that is utility, and you have it again and again. again and again. This is something, consensus, stability, this is what you want. So basically what happens is after distillation, features are learned implicitly that are not sensitive to viewpoint changes, that are not sensitive to things that don't matter. And we see this again and again. And then this is on a random scene that he took from online, from Bucharest. The same thing, random scene. Didn't see it. Of course, the other scenes that I showed you were not seen during training. We're just testing scene. This is a random scene that he found from Bucharest. This is maybe you visit. This is which is a smaller version of the original one in France. Okay, now if we look at the numbers look really good. So this is the number that we had at ICCD I just showed you, and here is the jump. From 53 to 50, from 40 to 55. It's a big jump, huge jump. And then I said, okay, let's look at consistency. And consistency also improves. We have a measure of consistency by using optical flow. Basically, what we are saying is that if I use optical flow, my label here should be the same as my label in front and my label behind. So consistency is something that we should see more often in temporal consistency. Just a second. So Nico talked about dancing. I'm not going to dance, but I'm going to play you some music. Let me reduce the volume. Because all these drones I showed you were piloted by myself. How about having drones that fly by themselves? So we have this place in the laboratory, or laboratory Polytechnica, which is really safe. It's actually an atomic bunker, and it's not anything else. So we can actually do this research with drones easily in a perfectly safe environment. So this is our drone. We will publish this soon. This month we'll send it to a journal. A drone that learned how to fly by itself. And it's doing a pretty good job. It actually doesn't crash. And not just that it flies by itself, meaning go around and just go randomly, don't crash, don't hit anything, go around. But it's also landing. It's finding its own base and landing. And it's all done by monocular vision. No other system or sensor. So we have several versions. Okay, and one test, no, the thing with this is one test takes 90 seconds, no, takes about a few minutes because the task is this, 90 seconds, survey, then land. So landing and flying takes a few, maybe 2 minutes because until it finds its base and then it goes. And you'll see the base kind of shows up with a different color. Segmentation and depth prediction is done in an unsupervised way. Metric depth prediction, we do it in an unsupervised way. I'll tell a few words about that. And segmentation with minimal human supervision. Basically, we give a few spots saying this is floor, this is that. And then we have this algorithm that starts to learn by itself. This is the helipad, and it's going to land now.
I have 3 more minutes.
Yeah, it's okay. And because this is the algorithm, we have a nice algorithm to actually make the depth metric. So actually, we have this safe flying safety corridor for flying, and it's not trivial. This is work with Sebastian Mocanu, who is here, and he's working a lot on this, making this work well. But then, of course, that in order to do several tests and not crash this and make this more efficient, we actually created a twin virtual environment of this. And here we can do as many tests as we want. We can crash the drone as many times as we want. And the nice thing about it is that it actually matches perfectly with reality. Now, we have 2 versions of the algorithm. One using only semantic segmentation, the other one semantic segmentation and depth. And we can see that so everything. So, for example, here, the red is better than blue. If you look at here, distribution of total distance. Or the blue, no, actually the blue is better because it flies more. So basically, how can you compare? Well, you say in 90 seconds, how much area you can cover, how much distance? The one that uses depth can go faster, can go safer, and it covers much more distance. What is the time to find the base? It's faster, and all that. So it's clear the 2 distributions are separate, and the only thing we have to remember is that by adding this depth prediction to semantic segmentation, the algorithm is much, much better, much, much faster. And then we said, okay, but how about, instead of having this complex system, how about we distill this system into a single network, a small unit of 1 million parameters that we can put on an embedded architecture. And embedded architecture is able to imitate, the distributions here are almost the same, imitate the complex system. but we still have to work on it because the embedded architecture starts to crash. Not much, but we need to work on this because now we are at 5 to 10% crash rate, which is not good. But we improve really fast because we add the hard cases, and as we add hard cases, we'll get 100%, I'm sure. But some checkpoints need to be done. So in any case, then if we want to go towards art, which is just one second, how about dancing with the drone? How about using that in a performance by simply coordinating this drone? And this is something you didn't see yet, but I'm sure that very soon, in a year or two, you start seeing artists doing this kind of things. We can coordinate the drone, no problem, because now we have the access. They recognize the gestures, the hand, I can do whatever I want to actually coordinate with this magician that plays with the drone. So this is an area that I'd like to explore also in the part of choreography or the manipulation of the drone with gestures, which could be really nice. Okay, and that's it. And now at the end, I left a video at the end, which I would like us to look at, because it puts together everything with all the scenes that we explored in Romania. And it's also on music, a recent song I made, especially for this meeting, in fact. So I hope you're going to like it. And that's it. That is my friend. I just happened to see him the day I was planning the flight, which is by very nice coincidence. Just one of me. Chance for the people who live at only. I will also share the video with you. So yes. So then we were thinking also trying to make things that are the combination of virtual reality, augmented reality with real scenes, which would be also nice. So thank you for your patience. I hope this gave a moment of relaxation and breathing in all this technical stuff that's going to follow. Thank you so much.
Thanks a lot. Okay, I would, for sake of time, because we are really late now, I would go to the next presentation of Nicola Tullarianti. Sorry?
Thank you. Let me put the timer. And yeah, thanks a lot for the invitation. I'm afraid I'll be showing a dry formula as opposed to inspiring videos and music. Yeah, that's what I can do. So this is about you know, the theory angle to some issues that arise in these projects. And the theory angle means that we are looking at specific domains of applications where it is interesting to reason from a theoretical viewpoint, meaning how can we design algorithms that have mathematical guarantees concerning certain properties. For instance, in this case would be transparency and fairness. And the application domain we'll be looking at will be that of digital markets, because digital markets, first of all, are very, well, are getting more and more pervasive, in particular digital platforms for handling a large range of activities. And also because they are very algorithmically very interesting. There's a very little friction between algorithmic ideas and their implementations on real platforms. So we can actually have, you know, some the kind of properties that you have in theory can be transferred in practical environments pretty nicely. And so the issues here is that users of digital platforms rely on data provided by platforms to make better informed decisions. And the lack of transparency can affect the quality of these decisions. And platform can take advantage of users in unfair ways, or platform can simply ignore fairness issues on the users. So the idea is to incentivize and design algorithms that incentivize transparency and fairness on behalf of the users. And we look at two case studies, are reasonably things that we do. Not every, okay, bilateral trades we do because we use Uber or Bolt, and first price auctions a little bit less, but it's something quite natural. So let me start with so can I just kill this one? Okay. Let me start with repeated first price options. So the idea here is that we have an auction, for instance, for selling impressions, so advertisements on a website. So the owner of the website, whenever there's a chance of an impression, will put it on sale through an auction, through advertisers that will buy the space on the web page to put their advertisement. And this runs in milliseconds, and by now is run prevalently using a first price auction. So in this case, we are going to have some unknown value of the impression. This is what impression is worth for the user that buys it, for the advertiser. And we have a bunch of advertisers. So this is from the point of view of a bidder, someone who wants to buy the space on the website to put his own advertisement. So there's going to be a bunch of competing bids for the same spot. And we're looking at the highest competing bid, which is the one that we have to beat in order to win the auction. Okay. I don't know what happens now. No, it's fine. No, fine. Okay, it just went to sleep for him. Okay, so the bidder will bid a number without knowing the value of the object that is put on sale, and without knowing the highest bidder, the highest competing bid. Okay, and then the first place price auction takes place, and the bidder will receive an utility that is conditional on the fact that his bid is bigger, or let's say equal than the highest competing bid, And the utility will be the difference between what it turns out to be the value of the object and its actual bid, their bid, right? So, for instance, here, the highest competing bid was $50. Your bid was 3/4. You won the auction, and it turns out that the value for you of the advertisement is $1. So you cash a net profit of 25 cents. Okay, so this is the idea. And at the end of the process, the bidder will receive some data from the platform, and the data is what will define the degree of transparency of the process. So now we want to study how much the extent to which the transparency of the process will affect the utility of the bidder. Okay, this is the idea. And we do this in an online learning framework. And so our measure of performance for how happy is the user is whether the user has small regret. The regret is the difference between what the user, with utility of the user summed over a sequence of options, and the utility over that same sequence of options that the user could have had it bid the best possible amount. Okay, so I'm competing with the best possible unknown amount of bid, and the corresponding utility I could have gotten with respect to what I actually have gotten through a sequential process. So this is a usual notion, which is called regret, that uses to measure online learning algorithms. So the per round utility, it could be, we assume that all numbers, values, valuations, and bids are between 0 and 1. Let's pick whatever unit you like, say dollars. And so your per round utility could be at most in the range of -1 and 1, because you can lose at most $1, or you can gain at most $1 in every round. So the total utility can at most grow linearly in time, and therefore the regret the regret can also grow at most linearly in time, and you want your regret to be sublinear in time. So in other words, we would like that your average utility in a sequence of rounds will converge to the utility that you would have gotten had you known the best bid for that sequence of the best fixed bid for that sequence of options. Okay, so that's the idea. And here, what is interesting is that we can look formally at different degrees of transparency. So there are two unknown quantities: the highest competing bid and the evaluation of the object, which we don't know we don't know beforehand. So there's a full feedback where we after each auction we observe everything. There is a transparent setting in which we, after each auction, we know what was the highest competing bid, and we observe the value of the object only if we actually win it. And semi-transparent is, if you like, is a bit more realistic in certain cases. So if you lose the auction, then I tell you, okay, you lost because that was the highest competing bid, so that you lost. And you see the value of the object if you win it, because then you have the object and you see how much it's worth. Okay, and the bandit setting is where you never know the highest competing bid, and you only observe evaluation when the object is when the auction is won. So now we want to study how much this degree of information this degree of feedback provided by the platform to the users are affect the utility of the user. So we were looking at the three environments. So how are these things being generated? The environment is generating this pair of numbers, and we have three models: a stochastic model, they are drawn IID from some fixed but unknown distribution; adversarial model, in which they are generated by some in an adversarial way, so it's a very hard setting. and smoothed models in which we have variants of stochastic adversarial in which we impose smoothness on the distributions. In the case of the smoothed adversarial, the distribution can change at every step in an adversarial way, but is constrained to have a bounded density. So you cannot have a Dirac measure on a certain evaluation and a certain highest competing bit. Otherwise, that would be adversarial again. Okay, so these are results. So these are rates of regret. So this is the smaller the regret for the bidder, the happier the bidder is. This makes sense. And so we said that we wanted the sublinear regret. So these numbers means that in these cases, when the environment is very harsh, or when the feedback is very reduced, like in the bandit, so this is the bandit setting, then there's a linear regret, meaning that the user is not learning anything, and it's super bad. This is the best possible rates, so the regret will grow at rate square root of t, which means that you're converging to the best bid at rate 1 of the square root of t. And this is true for the full information and the semi-transparent feedback, and for these kinds of stochastic IID in the general case, adversarial environment, but only in the smooth case. And then we have some intermediate rates here, t to the 2/3. So the user is learning the best bid at a slower rate because it has less feedback. And so the idea here, what is interesting to say is that the disclosing other bits, which is the transition from transparent to semi-transparent, right, so you see it here. So if you always disclose, if the platform always disclose competing bits to the bidder, then the bidder have a much better, a much higher utility, meaning a much smaller regret, with respect to situations in which the information transmitted by the platform to the user is as much smaller, like in a semi-transparent setting. Okay, so this gives you a way of really studying in a very detailed way how much the transparency of the platform will affect the rate at which the user learns the best possible, the optimal behavior. Okay, let me now say a few more things. So this is another quick, this is shorter, and it's another application for about fairness. So this is bilateral trading. So I went to the other venue this morning, and then I realized that, and I was panicking. So I got an Uber, which is really cheap here. And to get an Uber, I say, okay, I don't want to pay too much. And the driver will say, oh, this guy wants to go from here to there. So I want to get at least this much. So these are the numbers that we had in mind. And the platform, Uber, proposed me a price, which was ultra cheap. So I gave a 50% tip because just the driver was just great. So the platform, the Uber told me, okay, it's going to be for Leo. It's going to be for Leo. I said, fine. And also the driver was happy. And so the trade happened because the that was to both the driver and me by Uber was exactly in between what I wanted, the maximum amount I wanted to pay, and the smallest amount the driver wanted to get. Okay, I guess you got it, right? So yeah, and the only feedback that actually Uber gets is whether the trade happened or not, whether either both the driver and me accepted the deal he suggested. All right. So so these are the two numbers, and Uber doesn't know these two numbers. He has to figure out. He has to post a price which falls in between these two numbers. And if this is the case, we both accept. If this is not the case, we both reject. I mean, either, no, not, but at least one of us will reject. So utility in this case is defined to be the gain from trade, and which is the buyer's net gain and the seller's net gain for us, because I spent less than I was wanted to, of the maximum amount I wanted to spend, and so on and so forth. So this is actually corresponds to the difference times the indicator function that the deal happened. So it's going to be this red line. So this is utility for the platform, which, as I say, this is the gain from trade, which is the social welfare summing buyer's net gain and seller net gain. However, the problem here is that the platform may post a price which is very close to the buyer's price or very close to the seller price. So the two utilities for buyer and seller can be very much different. So this is not nice, because what we really want is that the okay, I'm almost done. What we really want is that the platform posts a price right in between the two prices, so that the minimum distance between the two, between seller and buyer price is minimized. So that will be a fair offer in which both of us will have the same utility. The driver and myself will share the same utility. So notice that the platform never sees this utility, but we can still define regret in the same way we did before. And we can make some observation about these two quantities are not very well related. In particular, minimizing this gain from trade is not the same as minimizing the fair gain from trade. So we need a specialized algorithm to ensure that the driver and the customer will have the same utility. And we can show that there are algorithms that will be able to control regret in both cases optimally. And this is achieved by different algorithms in a specific environment. And for gain from trade, you need additional assumptions. So again, I mean, we can ensure fairness in Uber offers. But we need to use algorithms that are specialized to that particular social welfare definition. So we have other applications, but it's ongoing work, and I think is a very nice and exciting line of research for algorithmic design and learning. Thank you very much for your attention. Okay.
Let me ask a question now, because I'm just curious.
Okay.
What if you had some extra information? In your particular case, what if you knew that walking would be faster than just taking the...
I didn't know. No, I found it out later.
So that's why the price was so low, because it would have taken you like 5 minutes walking while going around.
No, but the address was on the off.
No, I mean,
I was panicking.
So how can you incorporate this information into your model?
Yeah, so this is side information. So you can, all of these problems I presented are without the context. Yeah. So you can have a feature vectors that come at every round. Feature vectors for the ride would be like exactly the kind of information that Nico was talking about. Feature vectors for the auctions would be related to the kind of customer, so the kind of user that is willing to visualize the web page, what kind of HTML headers or other information you can get from that user, and the kind of impression, so the context of the impression. And this is also so you can replicate these studies by adding contextual information, and becomes a different thing. So you have to do everything from scratch. But it's definitely an interesting direction of development.
Let's move to Joanna now. Thanks again, Joanna.
Thank you.
Joanna, welcome from Ingegneria.
Okay. Should be here. I present them from here. Okay, no, we can do it better. Okay.
Okay, thank you, everyone. Very glad to be here and talk about some of our team's projects in a space that I'm going to just globally label data and AI for a digital democracy and for a trustworthy digital democracy, that is. I have chosen to speak about several of our projects in a way that tries to maximize coverage of what we are doing. We would be very glad to collaborate with anybody who's interested on this. Send us your students, we can send you ours. It would be very nice to do things together. So I'm going to give a brief overview of our team. So my team is called CIDR. It is a joint team between INRIA and École Polytechnique, which is a reasonable counterpart of the Polytechnic University that hosts us today. We are 5 permanent people in the team. My colleagues, you will be really interested to know that we are 3 Romanians and we come from 3 different universities and we only met in France. So this is my colleague Oana Balalo, who specializes in natural language processing. This is my colleague Oana Buga. She specializes in ad studies and in detecting manipulation campaigns online. You have myself here. You have my colleague Yan Legiao. She comes from the States. And my colleague Madhulika Mohanty, who is a junior researcher and a graduate of IIT. The general areas in which my team works are big data management and analytics, NLP, as I said, and these internet studies and large platform studies, where Oana Goga specializes in devising user studies that are actually eliciting user data with their consent and studying what information people really get pushed on social networks. So this is what she specializes and she knows how to do. Many of our projects are motivated by trying to help data journalism, because we believe that trustworthy media is an important actor in the information space. And one of the things that we notice discussing with data journalists is that they get very heterogeneous data that are in a variety of formats. It could be PDFs, it could be JSONs, it could be graphs, it could be documents, whatever. And they just get these sources because this is what they could put their hands on. And nobody has the time to design a data integration platform and massage the data and do the ETL that may be necessary in order to exploit it. And of course, journalists are not technical users, so they don't have data literacy. Those of them that know how to work with Excel are considered tech savvy. And it is difficult to try to talk them into having a real data management architecture. I mean, there's a significant, let's say, a skill gap there. And what we learned from them is that their data sources from a user perspective, which is the perspective that should interest us, features common actors and common concepts and common players. When they do an inquiry about, let's say, a company or a network of companies, what they want to know is how do these things connect? And they know more or less what they are looking for, but of course, they're also interested to see actors emerge from the corpus that they didn't foresee initially. So we had a project that included lots of our research where we try to build systems for what we call digital arenas. The idea is that users, in particular journalists, can bring data sets of any format, and we are going to integrate all these data sets into a graph. Why a graph? Because it's the most generic format that we have that can still capture fine granularity structure of the original data sets, and we enrich them via entity extraction with trained language models, of course, and also with more dedicated application-specific algorithms, relationship extraction. And the last iteration of the relationship extraction work involves Garima, who is here and who can tell you more about it. So what we do here is we integrate very different data sources into one single graph. This one you can't see very well in particular because we have the sun, but the sun is nice. What I want to show you here is just this particular use case that came from a journalist that works for Le Monde. She was interested in conflicts of interest between experts that arise when experts that advise the European Union on the toxicity of some substances are or have been paid by the companies that make those substances.
So what we did here is we took publications of biomedical experts. We took the BibTech notices that say this person published this paper, paper author, title, and so on. And we also took the statement of conflict of interest that are present in the bibliographic notice, but we even took the papers themselves to harvest more phrases from the paper where people show or thank various organizations for helping, you know, the acknowledgement paragraph. So what we found here is that there is this German professor whose name is Helmut Grein. The green note here symbolizes a person that has been recognized by a language model. And he has authored several papers. Here there are actually 4 papers signaled by the 4 red root nodes. The papers are all interconnected because there are common co-authors. Like there is Grein here, and there is his colleague Volker Mostert here. And in one of the papers, Helmut Grein says that too much transparency is hurting technology because we can't develop new molecules if somebody is always asking us how did we do it and asking too many questions about the toxicity. And here he says, we claim no conflict of interest with respect to this research. Whereas in another paper, he says, we thank Monsanto for preparing the data that was used in this paper. Okay, so what happens is that on one side, the person says, I have no conflict of interest whatsoever. And on the other side, they acknowledge a company that has based paper and just bought their signature. So we managed to make this link between PDF documents and bibliographic notices and what have you, because we find the common entities that connect here being the people and over there being the company. This is the kind of benefits that we get by integrating heterogeneous data sources. I'll now switch to another project that was briefly mentioned yesterday, which is more in the area of fact-checking. And here we go at the very heart of digital democracy, where there's a public space and people make claims, people make statements, and somebody makes one of these statements. It could be on a social media, it could be on TV, it doesn't matter. The point is we have a statement and we try to think, you know, what should we think about it? Does this hold? Is this true or not? Is it information? Is it misinformation? Is it disinformation with a typo or without the typo? As you will see, I have it with and without the typo. But the point is, we are trying to evaluate the statement to know if we should trust it or not. And to evaluate it, we typically rely on some source of authority. For instance, it could be past statements, or it could be connections between the speaker and some other organizations. Right? Like if this person has been paid by Monsanto in the past, like we have just seen, maybe that gives me some context to interpret their statements, or maybe they have been paid by somebody even more nefarious. We may also check a statement simply by consulting some reference data when some reference data exists. So for instance, when somebody says that that many billions have been spent on a specific type of expense, if there is a reference source that says, no, it's not that many billions, it's less than, then you can say, look, we have reference data, and the reference data disagrees. So we see all this is a data management problem. And if you think of the reference data of the source connection and of the past statements, all of this can be used to check a statement that is made today. And an important category of content that you can use to analyze a statement made today are previous fact checks. So if you check something and you say this is true, or this is partially true, or this is false, the check that you made is a data source by itself, which can be reused. In particular, if somebody has made many unsubstantiated statements in the past, then that can go towards a bad reputation. And conversely, if a source has been typically making true statements, then you can think that these people are not necessarily crooks. Maybe they may connect mistakes, but they're not crooks. So this leads to what we call a fact check retrieval pipeline, where we have given a statement as an input. And with this statement, we search to see if there already exists a previous fact check on this statement or on a similar one. If somebody checked the statement very recently, we could just reuse it because, of course, many media listen to the same claim. So if somebody already made the check, there's no point in another media agency or another fact checker investing energy to check it again. However, as you probably know, there are also a lot of false information that is made by repurposing old claims. The old claims could be true or could be false. Something that keeps popping up in France, as soon as there is a government minister that is part of what we call a visible minority, doesn't look like the standard French, white French person. Immediately, they are assigned some fictitious criminal children. So this has happened with two successive government ministers, one from the left, one from the right. Both were part of the visible minorities. And there was one idea that she has a son that is in jail or was in jail and is a drug dealer because, of course, a minority person, their children are said to be drug dealers. So when you find that it's exactly the same story, you can use old fact check to understand that the new one is basically just repurposing the same old lie. So now from a technical perspective, we are getting there. We are starting with a claim that is a phrase or a social media post or maybe an image from which you can take the text. And there are compound fact checks that are on open access, which have a title, a publisher, a date, and a few other fields. There is a claim text, which is what is the claim that we're checking. And there is a URL to article, which points to the wrong article. The title is typically related to the claim text, but it's not always identical. So this is the kind of data that we have. And the fact check retrieval problem is a two-step process. First, we need from a potentially large set of fact checks, given a claim, to find possible candidates. And second, we need to rerank these candidates to determine which are the most relevant for this. And typically neural methods, in particular transformers, are the best tool for this purpose. So the fact check bureau that was briefly presented yesterday, which again has Garima at the lead, so you can ask her more for details, is a platform which supports building fact check retrieval pipelines. On one hand, for data scientists or computer scientists that really understand what they're doing, and which can try several language models and several methods that can be easily composed with some drop-down menus, do this, do that. And on the other hand, once the scientists are happy, they can freeze a pipeline, give it a name, and then non-technical users can just come and use the frozen pipeline that is already there in order to do their own fact check retrieval. That is, there is this statement, has there been a previous fact check on the same topic? And you're going to say, but who's going to give me all the previous fact checks? Well, Google does. Actually, Google just introduced a standard format, and then an organization formed around it, the International Fact-Checking Network, which pushes online hundreds of thousands of so-called claim reviews. A claim review is basically a fact check or a claim analysis. So people said this is what they said, this is where they said it, this is what we know, this is our conclusion. And we also built a corpus by gathering all this information together with a few thousand tweets. Some of them were mentioned in the fact-checking articles, and we also paid to acquire tweets ourselves. So we took tweets over the summer of 2024 from members of the European Parliament, and we experimented with this corpus, in particular English and French. And there are some technical insights with respect to the quality of the retrieval process. I will point you to the paper for the details because, anyway, oral delivery is not the best modality here. And in the same area, a distinct project that we have undertaken is to facilitate fact-checking that is based on statistics. So all developed countries have some statistic institutes that pay public servants that compile numbers about how many people are born and die and how many people graduate and production of potatoes and cars and space rockets and what have you. And these numbers are usually very precious because they have been compiled by specialists. And these numbers can be used to quickly verify claims that refer to these numbers, of course, because typically in France, at least, people often refer to unemployment, employment, or immigration. These are the hot button topics that we have been talking about. And what we did is we built a tool that harvests statistics from major statistic institutions. The name of the tool is StatCheck, and which provides a simple form where people can search for statistics on a given topic, and which has a coverage that is much better than what search engines give you, because search engines, as we have shown, do not crawl all the do not crawl a statistic website in full. They only crawl a small fraction, and we don't really know how much they crawl, but we know that if you ask Google for a certain statistic, you may not get it, whereas it's there, just because Google didn't think that the whole of the INSEE website was worth indexing. Okay, because I think it's really important to respect people's schedule and all of our colleagues, I'll stop here. There are a few more slides that I had, but I'd be happy to talk about them at the break or at any other point. Thank you very much for listening.
We have time for one question. I'm just curious about this kind of, I mean, one issue you have, of course, with fact checking is that it's a kind of zero shot in the sense that you don't have a lot of data on that. Can you use some generation, some kind of hallucinate these kind of things, something that is but something that is plausible that you can train your model to obtain like a retrieval augmented type of generation, I mean.
My experience has been that we're not lacking data.
Okay.
Like we have one student who we put to the task of harvesting the integrality of the stat. So we give him a website and say, come back with all the statistic tables that all the tables that this website contains. So he had a reinforcement learning crawler that goes and finds all the tables. Gosh, there are tables. So, you know, you put him on an Australia website, statistic website, he brings you back like 12,000 tables. You ask Google, how many XLS files can I find within this website? He says 212. Okay, so we do not lack data. We do not lack data. Now, the thing is, some of them are structured in a perfectly machine understandable way. And then there is Excel. Okay, so Excel, which is favored by some statistic institutes, unfortunately, including the French, has irregular structure. So the automatic exploitation of that is more of a pain. Okay, but data is not lacking. We lack a reliable, precise, and a good understanding that can basically, that's what we do for these well-behaved cases. We're given a query, like here I said that the average of CO2 emissions for France 2010, it can find you exactly the number. It shows you the header of the column and the header of the row so that you can trust that, you know, this is where it came from. And always the link to the original statistic file within the website, always with the source, always with the source.
Okay, let's take a break now. We can be back in 15 minutes, like 11:20 or so. Thanks. Good. So welcome back. Now we are moving towards safety, bias, fairness, and let's the floor to Lorenzo Maraldi. Thank you. Maybe use a microphone. Yes.
Do you want to drop the lights because there's a lot of lights on this?
I could. Assuming that it. No.
I think it's the same.
It's the same. So go ahead.
Okay. So good morning, everyone. And so, yeah, as Nico was anticipating, we are moving a little bit towards safety. And I will show you some of the things that we have been doing about this in Modena, and not only Modena actually, because also Nico is working on this. So the point from which we start is that unfortunately, to develop large-scale models, we have to scrape data from the web. And of course, when you do this, yes, you collect lots of data, but unfortunately, you can also collect unsafe data. And this has a very practical consequence on the ability of the models, which can indeed generate harmful content. And this is very visible, for instance, if you ask to Stable Diffusion to generate something which is unsafe. You have two examples on the bottom right side of the slide. So for instance, a two-engine train crashing into a truck or whatever, it will generate this because it has seen this in the training distribution, and of course, analyzed to all the things that it has seen, so it can do this. Or a close-up of a baby on a table with blood all over it. Yes, it does generate this. And this is, of course, pretty expectable in the sense that it has seen any kind of data during the training, so it makes sense that it can generate any kind of data. But of course, that's not really what we want, or at least it's something that we not always want. So we asked ourselves, how can we make those models more safe by either removing or managing this sensitivity to unsafe concepts? So we developed two models, and we will go through them in order. The first one is SafeClip, in which basically we take an existing clip model and fine-tune it to remove any unsafe content from it. So basically, it will be a model which will behave as if it has never seen unsafe content, which is already something in the sense that it will never generate, or at least it will rarely generate unsafe things. And the second one is Isaac, which is our latest model. Instead of just unlearning or removing the knowledge of unsafe things, it does safety preservation through awareness. So we will leave the user the possibility to generate or not unsafe things, which is, so to say, more aware than the previous one. Of course, before going through the two models, we had to define what we meant for unsafe things. And we followed a definition that we found in a previous paper. So not safe for work, list of categories, so hate, harassment, violence, and so on and so forth. Of course, it's not complete, and it's very coarse-grained. We know this. We are kind of working to make those categories more fine-grained and more comprehensive. But for the time being, we will stick to this. And once we have defined what we mean for unsafe, of course, we needed a data set, at least for evaluating the sensitivity of our models to data, and potentially also for fine-tuning them to be more safe. So we needed a data set with pairs of safe and unsafe things. And we asked ourselves, how can we do it? Because of course there's no data set with these features already available, so we had to build it. And the way in which we did this was to start from safe sentences, which are the ones that you see on, which of course is very easy to collect because you can just take sentences from any existing data set and build a generator which can translate safe sentences to unsafe sentences. To do this, it was actually surprisingly easy in the sense that we started from Llama 2 Chat, which at that time was kind of the state-of-the-art open source LLM, fine-tuned it with just 100 pairs of safe and unsafe sentences, and it started working. It started generating unsafe. which is, of course, kind of worrying in the sense that we all think that those models are kind of safe, and actually it's not true. You give it 100 samples, you fine-tune them, and they immediately start to generate wrongs. It was actually useful in the sense that we had a generator at this point which could convert safe sentences into unsafe sentences. And here you have two examples. Notice that they kind of maintain the same semantics, which is something that we wanted. So if you start from the yoga is just a part of your life, you will end up with drugs are a part of your life, and so on and so forth. So more or less it maintains the same structure of the sentence and the same meaning apart from injecting things which are not safe. And once we have this, we were already kind of way to get the full data set, in the sense that we did the same thing for the visual part. So given the unsafe text, we took Stable Diffusion-like generator trained on unsafe things and started generating unsafe images. Result, we have this data set which we called VISU, which is basically made of quadruplets with safe text, unsafe text, safe image, and unsafe image. And with this, you have basically this quadruplet from which you can start training your models. Of course, yes, we had to generate unsafe things, but it was for good, in the sense that we did this for actually making the model safer. So let's see how we could use this data to make CLIP safer. The idea in Safe CLIP was pretty easy, I would say. We took the original CLIP and fine-tuned it so that it would ignore the unsafe content. The idea here is basically that if I feed an unsafe item to CLIP, could be an unsafe image, could be an unsafe text, it doesn't matter. The embedding that the model will produce is requested to be the same of the corresponding safe item. So if I give you an image of an airplane crashing into a building, I want the model to generate the same embedding that it would generate for this image of an airplane, which is completely safe, of course. And the same applies for the text, same reasoning for the text. So at the end of the day, basically you have a model which kind of ignores the unsafety of the content, in the sense that it will give you the same vectors that it would produce for a safe image or for a safe text. After this, basically you have an embedding which is clean, in the sense that it does not encode unsafe things inside of it. With this, you can basically do anything that you can normally do with CLIP. So you can just replace your ordinary CLIP with safe CLIP, and it will still work. It still works because we also added a kind of geometry preservation loss, which maintains the same structure of the original embedding space as much as possible. So you can actually take those embeddings and connect them to your favorite image generator or your favorite multimodal LLM or whatever. So here are some of the things that you can do. You can do text-to-image retrieval, of course. You can do image-to-text retrieval. If you feed it with unsafe text, it will come up with safe images, or vice versa with the unsafe images. You can generate images starting from prompts encoded with safe CLIP. And you can also, of course, describe images or prompt a multimodal LLM to do image-to-text generation. Here are some of the examples of how it works. So this is text-to-image. You will see unsafe queries, and the top one, image retrieved by CLIP, which sometimes, most of the times actually, it's unsafe. And the one retrieved by us, which most of the time, since that is safe. And on the right side, you have image-to-text, which is the opposite. So we give it an unsafe image, and we see which caption it retrieves. And numerically, if you compare this with CLIP, or even a CLIP trained on data which is supposed to be completely clean, even though it's not completely, it will retrieve less unsafe content. So we're definitely happy about this, in the sense that this is what we want at the end. And here, some results about the generation instead. If I prompt the model with unsafe prompts. So the first column is what Stable Diffusion would generate without any cleaning procedure. The two intermediate columns are existing methods from the literature to try to clean the generation. And the last column is us, so safe clip. And again, it cleans the generation most of the times. And this is also visible from the table at the bottom. Last example, the opposite. So image to text generation. Here we take Lava because it was kind of super popular at the moment. We still didn't have Idefix, so we couldn't try it. But the idea is I give you an unsafe image and I ask you to tell me what's inside. So the original Lava sometimes identifies the unsafe content, so it starts actually doing its job, so saying what's inside of the image, regardless of the unsafety of it. If you just take the embeddings from safe clip instead of the ones of the original clip, it tends to be more clean, which again is what we wanted. So less generation of unsafe text starting from unsafe images. So that kind of all about safe clip. So the idea again here was to clean the embedding space, so make it, so to say, unaware of unsafe content by just saying, hey, if I give you something which is unsafe, I want you to respond as if it was safe. So that's one possibility, of course. Then we also took another complementary, so to say, path, which is instead of unlearning the unsafety, instead of teaching our models to behave as if the content that we give to them was safe, we want to promote awareness. So we want to encode both safe and unsafe concepts in our embedding space instead of just making the unsafe collapse towards the safe, and leave the potentially the user the ability to say, yes, I want to see unsafe content. No, I'm in a sensitive context, so I don't want to see unsafe content. Which also makes sense because there are some of these categories which maybe you will never want to see, or some of them which maybe in some contexts make sense to see, and in other cases do not make sense to see. An instance would be an image of a war, for instance. There are cases in which you might want to see it, and there are cases in which you don't want to see it. So it makes sense to give the model a little bit more flexibility. So that's the latest model that we did. Here we completely changed, so to say, the geometry of the model. It's hyperbolic in this case. It's not Euclidean anymore. I don't know if you are familiar with the hyperbolic, but it's basically a space. That circle is a top-down view of it. You should imagine it as basically as a cup that grows infinitely, exponentially actually, as you go farther away from the origin. And if you see a top-down view of it, it's basically a circle. And the thing is that the origin is in the middle, and as you move forward and you go farther away from the origin, it grows exponentially. And this is known in literature for being capable of encoding hierarchical things because it grows exponentially. So if you try to encode hierarchies, it naturally adapts to the fact that the hierarchy will grow exponentially as you move towards it. So we exploited this. So basically, we are taking the embeddings of a clip and projecting into this space and organizing the things inside of this space. And the way in which we organize is basically very simple. So we want the safe content to be more closer to the origin, and the unsafe content to be farther away from the origin. So to be a little bit more detailed, these are the two losses that we have. We want the text to be a little bit closer to the origin rather than the images, because we kind of postulate that the text is more abstract than the corresponding image. This is something that other people have done in the literature, so it was already there, we just took it. And the second objective is the unsafe image text parts are more specific than the safe counterparts because they contain something that the safe counterparts do not contain. So this is the second objective. So we have two loss functions for modeling this, plus the usual contrastive loss function to make sure that an image stays closer to its corresponding text content. So the final geometry that we have is something like this. The red point is safe content, the blue point is safe content. So we want the safe content to stay closer to the origin and the unsafe to stay on the periphery, so to say, of the space. Once you have this, how would you retrieve items from this space? Well, the good news here is that because we have placed safe and unsafe things into two separated regions, we can immediately know whether the query that the user has given to us is safe or not, which is something that we couldn't know in SafeClip because the embeddings were basically collapsed into the same embedding. Once you have the query, you know whether it's safe or not, and you can retrieve safe content if it is unsafe. The way in which you do this is you take your query, you move towards the origin until you start finding the safe region, which is closer to the origin. That's the formula basically. So you take the direction connecting your query to the origin, and you move towards it by an amount which is sufficient to bring you into the safe area, so to say. And then you do this is basically your new query, and you do the retrieval there. Of course, you can also do the opposite, so that's why you have awareness. And few experimental results. It's the only embedding space. This is the Isaac embedding space, so the embedding space that we're doing for safety. It's the only one that can separate safe and unsafe content, and safe images and safe texts. This wouldn't happen in SafeClip, clearly, because we have an objective that does exactly the opposite. It doesn't happen in Clip, because the safe and unsafe things are more or less at the same distance from the origin. And this is another hyperbolic embedding space, a traditional one, which is not trained for safety, and again, it cannot distinguish the two things. It works better than SafeClip in retrieval, so it's safer than SafeClip when it comes to retrieval, which is a good news. And it works on real data, so on real unsafe data, better than SafeClip in most of the cases, which again is good. And it also maintains the capability of the original clip a little bit better than SafeClip, which was one of the issues of SafeClip. There's still, in some cases, something to do, so it's not over, but more or less it maintains the original capability. And last thing, which of course SafeClip couldn't do, it's also a safe and unsafe classifier. So if I give you something, it can tell me whether it's safe or not. And if you compare this with existing safety classifiers, it works decently, pretty good. So which is also nice. It's kind of an additional feature of it, but I think it's nice. And finally, just a visualization of it, just to play a little bit with it. Here we are giving the model an unsafe image and doing retrieval with it by basically moving our query towards the root of the embedding space. So we visualize how things change as we move towards the origin. So if you do retrieval without traversing, so without adjusting your query, it will retrieve unsafe content. And as you move towards the root, it will start instead retrieving safe things by more or less keeping the same semantics. So for instance, here you have a train which is crashing. And if you move towards the origin, it will retrieve something. The train is going over the bridge, over a river, so which is more or less the same thing, but without the unsafe content. And which is basically what was happening in SafeClip, but in this case, you have a little bit more of control. And the same for all the others. So of course, it's an alternative approach to safety. It works better than SafeClip, and it also gives you a little bit more awareness, which might be also interesting in some specific cases. So that's it. Of course, thank you.
Yes, I have a question. So in the original clip, they used the zero-shot performance on image methods like proxy for how well it generalizes to downstream class like image generation and so on. My question is, are these methods, like how well do they still perform on original zero shots? Is there any degradation and so on the general class?
So in both cases, it's actually a form of fine tuning, so that there's the risk of losing the original zero shot performance of clip. With safe clip, it was kind of an issue. I mean, it wasn't losing incredibly a lot, but it was losing a bit. There's a table in the paper with some tests in zero shot. In safe clip, in Isaac, so in the hyperbolic one, the situation is a little bit better in the sense that with the hyperbolic space, we lose less with respect to the original clip. So we kind of maintain it better. Although, yes, it's probably the most worrying issue in some sense because you make the space safer, but if you do it with fine tuning, you tend to lose a little bit in terms of the original capabilities. Not incredibly, so it's not super worrying, but yes, that's one of the points. I don't know if Nico will show his models, his take on this.
We'll see how.
Okay, there's an alternative to fine tuning, which is also interesting from this point of view. And let's say what Nico says.
Okay, thanks, Laurent.
Thanks.
So I will continue on the same line. So my goal was here. I'll try to make it a bit faster because we are running out of time. But I wanted to do a walkthrough the things that we are working on: fairness, bias, and safety. And we'll see how we stay with time. Probably I will connect to what Lorenzo was presenting. So we started from a simple observation. If you just take your favorite whatever generator, stable diffusion Excel in this case. You have a query, like a picture of a person in the kitchen. What you observe is that there is a clear bias in there. And the bias here is related to the person gender. Okay. Of course, the prompt in itself has nothing to do with the gender, but for some reason, stable diffusion Excel has kind of learned that if you talk about a person in the kitchen, it must be a girl or a woman or so. And then actually what you do, if you just change now person to a chef, you just go into whatever. It doesn't mean that there are no female chefs, but still the model, even there is no information about the gender. The model will kind of generate now they are all male and well, they have the funny hat and so on. Okay. So this was something that we wanted to look. So what we have these unexpected biases, and given an attribute agnostic prompt, the model may generate images with specific attributes, right? So you do have low diversity. So our goal was to try to see how we can go around this type of situation, right? So we were looking into this fairness. In some cases, of course, this is an innocuous type of statement, but in other cases, you can get to some sort of, very kind of politically incorrect type of generation. So what we did, we started first with looking at face attribute classification, and that was the paper we had last year at Berkeley. And given, for example, an image of a face, and you want to classify some facial attributes, like, I don't know, straight hair, you may, of course, in some of your training set, you may have some unlabeled training data sets. So you may have some specific facial features, maybe more prone to specific protective characteristics. For example, one clear example will be race. You may have in your training data more Caucasians rather than Black people or Indians or others. Okay. And what you want to make sure that you are analyzing this bias and you want to mitigate it, what you have in there. Okay, so what we did. Practically, you just start with a real data set, which is biased. You can analyze that is biased. You have, I don't know, more females or more white females. You want to make the data set more fair in the sense that you want to somehow to balance it. What you do then, you understand what are the biases in there. you are just generating in your feature space, you are generating images of people which have the desired characteristic in order to balance. For example, you generate darker people and so on. And this can be done by using a synthetic data set, right? So you can just have some synthetic data that can help you do the generation. And then through the contract leap or whatever other model you use in there, you can just manipulate the data. You add it to your real data set. And then based on that, you can go to the downstream task and you can show that indeed the bias is at least controlled up to a point. Okay. Well, this is more like the scheme that you have in there. You start with some, you get a generative model, could be DeFi in that time, but could be anything else, it doesn't matter. You have a synthetic data set, you generate this new data using some pseudo labeling, so depending what kind of things you want to do. You get your real data set, you see which bias you have in there, and based on this, you try to manipulate your data space so that you are generating now different distribution of your data, and based on that, you are augmenting your data. Right, so that was the thing that we had for faces. And of course, how you generate in the faces, you just go into the latent space and you take some these transversals through the latent space and you do the generation. You go from kind of original image is more like kind of whited person, and you get some kind of darker person, for example, here. And you can also play around with age, you can play around with skin and some other kinds of things. One issue with these things is that you need to kind of know a priori what is a bias, or at least you need to look at the data set to see what bias is there. And that was what we call it the closed set. What we did after that, and that was a paper we had, it was a highlight at CVPR last year. We proposed what is called open bias. So practically what we do, you say, we start with a prompt, let's say a person using a laptop and so on. And we were asking ChatGPT to tell us what kind of biases can you get out of this prompt. And it could be a person age, could be person gender and so on, but could also be something like, laptop brand, something that you would not imagine. So the ChatGPT can give you this information, right? So it is in some sense, it is an open world because we are not restricting to anything, right? And based on that, now we go into our data in the similar way what we had, and we verify that that particular bias does exist. Okay, so we have this pipeline in which you are proposing some biases via in-context learning on a large language model, okay? Generate the synthetic images with a target generative model and the given caption, and then you are just checking the proposed biases via, we have a visual question answering model on the synthetic data set. Well, so the scheme is more like this. So you start with a set of predefined prompts. You go through the LLM, you get a proposed bias, could be person gender, train color, vehicle types, and so on. Based on that, you are just trying to understand, you take, for example, person rates, and you are asking what sort of questions related to the gender. For example, what is the race of the person, what is the race of the person throwing the frisbee, and so on, according to the caption that you have. And based on that, you have a list of classes of races, Caucasian, African American, Hispanic, and so on. And based on that, I'm just manipulating my synthetic data set so that I am quantifying how the data set is manipulated. And then you can get this type of example. For example, if you get an example is the train zips down the railways in the sun. And for some reason, the trains, most of the trains that you generate in this way are yellow. Okay, and this is some kind of unexpected. I mean, you haven't seen so many yellow trains. Probably in India there are yellow trains. So for some or some other places, I don't know why necessarily the generator will generate these yellow trains. Or you have a photo of a person on a laptop in a coffee shop, and you have most of them are just female, but you can also see that the laptop brand is just an Apple. Okay, for some reason it's an Apple. Or you can get horse breeded or other kind of things. Yeah, so these are some more other examples. I'll look into a little bit more details on this one. So you have a small child hurrying towards a bus on a dirt road. The funny thing is that there is no bus in there, even if you say that it should be a bus. And then, of course, the child, they are all black child. The black children, right? So we were wondering, I mean, fine, but this has nothing to do with, of course, with what we generated there. And this made us consider looking at individual words and try to understand what is the particular word that is generating this bias. And in this case, it's kind of easy to understand, right? So you would say, what if now I have the query like a small child hurrying towards a bus? So I'm just taking out a dirt road, right? You can say, yes, in Africa, there are many dirt roads, and because of that, it's kind of associated with black people. And indeed, if you just do it without, I guess I still have the prompt in there, probably not. But that will be the result without the dirt road. And now you see all the childs, or both of the child are just white child, and now you can see the bus. Okay, but again, you get another bias because now the bus is the yellow bus. So in some sense, we go now to the American type of buses, right? So what you do, you just move around on this type of things, and you just look at these words and try to understand how this is working. And actually, what we did, this is the extension of the work is now in PAMI in minor revision. I go very quickly through it. We call graph bias. So we are looking at which words, which prompt words are contributing more to the bias. Right. So for example, you say a picture of a doctor. Here you have a gender bias. Clearly, that's probably here doctor is, or maybe you have to be a bit more specific. And we have the same pipeline as open bias, but here practically what we are looking at the gradients. So you see every word, how are they changing the weights of my network? And this means that if I have a big change into my gradient, this means that that particular word should have a larger impact on the bias part. So here is the gradient part. What we do, we are looking at the gradient for chef, kitchen, standing, whatever. We rank them in a particular order. And from there, we just take and say, yes, maybe chef in this case should be responsible for that particular bias. Right, and manipulating this weight, I don't have a lot of details in here. Manipulating that weight, you can also control what's going on in the bias, right? So the good thing about this is that it's not only that now we discover that there is a bias, but we could also try to manipulate to see that these particular weights are responsible for the bias and particular words that are in there. Okay, so here are some qualitative results. The one with the chef and the person. You see that, you know, the chef, it will probably male bias, while person will give you more like female bias. You get, I don't know, things like laptop brands, so with person or teenager and so on. So you can play around with this particular word. Here we were looking at the nouns. We didn't look much on, for example, verbs. Of course, it's far more complex. So for an NLP point of view, our analysis of the words is very, very, very simple. Of course, it's far more complex because it's not only that the noun in itself, but could also be, I don't know, even some adjectives can change things, right? So you say, I was in a party, or I was in a bloody good party, or I was in a bloody party. So just to relate to safety, right? So it's language in itself, it's very complex. So based on this, we also move towards safety. And well, of course, we were aware of what our friends in Modena were doing. And what we realized is that SafeCliff really works. And then Lorenzo showed you how it works, and it's very good. But one thing that they didn't consider was that in many cases, you may start from a safe prompt and still generate unsafe content, okay? Which is kind of unusual. It's counterintuitive in some sense. But if you can imagine, again, we were talking about biases in some sense. I don't know, I can give you an example, like you have a picture of, he had it somewhere there, a picture of two ladies, or two beautiful ladies on a bed or on a sofa. There is nothing unsafe in there, of course, but for some reason, the model has seen many beautiful ladies on sofa doing something else, and kind of tend in some cases to generate unsafe content, even if, of course, in the prompt there is no safe, there is no unsafe request in there. So what we were looking is that some of the large-scale data set met safe unsafe content, and what we want to do, we want to look into this unwanted safe behavior retrieve unsafe images from a data set and encode this unsafe concept and try to make them as far as possible from the safe content that are in there. So we were looking at removing this unsafe behavior, so fine-tuning techniques. You unlearn unsafe concepts, so we are not doing what Valentin was saying, closer to the safe one and preserve the original embedding space, right? And we also preserve high performer on unsafe queries. Sometimes you have this unsafe behavior on safe queries. So this is what was the safe clip that Lorenzo was sharing. And now what we were also manipulating the weights. So looking at now, since we are looking at the weights of the model, can we localize unsafe weights? So which weights on my network are responsible for this unsafe content? We prompt the visual language model with safe and unsafe data. We start the unsafe and safe weight activation, right? So you estimate the unsafe contribution, and then we manipulate the localized unsafe weights. We want to have the small amounts. For example, we are inverting the magnitude. So kind of say, well, I'm just turning it down. So now I say, well, if I would discover that those will be unsafe content, we just kind of manipulate that way, so we turn them down. These are some losses that we have in there. So we have some layer-wise unsafe score estimation, layer-wise safe content estimation. We do some aggregation, and then we are manipulating stuff. The interesting thing is that we are using very, very small amount of the weight. So this is more like 0.02%. So it's very, very little. So the manipulation that we are doing, it's very minimal. Right. So this is by manipulating these weights, we are preserving safe behavior on safe queries, and this is quite important what we wanted, and remove unsafe behavior on unsafe queries. So from this point of view, when we have unsafe behavior, when we have unsafe queries, we are preserving the safe clip performance. Well, so this is some numbers, and well, that's some of the things. So it's the small amount of the weights are manipulating. So we talk about 0.02% of the weights. So in the end, well, we also have some novel metrics for evaluating the model safety, and just shows that by localizing the specific weights, unsafe that encode unsafe concept, we are able to obtain good model preservation capabilities and good unsafe concept removal. And this paper has been rejected by CVPR, not because the reviewer didn't like it. It was kind of yes. I mean, we wrote it at the very last moment, so there were some things that were let's say not so well explained. Now, of course, it will be submitted to ICCD, so we'll see. So we were not as lucky as they were with hyperbolic clip. Okay, so that's what I wanted to present to you. Well, if you have questions. So Isabel wants to clap their hands, so thank you. If you have any question, yes?
Did you think of using sparse encoders for mitigate bias, or what's your take on this recommendation?
I think we tried a few things. I'm not sure about the sparse encoding, but I'll tell my students to look into. I think it should be a good way of doing this. Also because there, of course, you would have probably less nodes, and probably this could help a bit, especially when we are looking at the weights. But anyway, I think it's a very this area is still very open. I think that it's a lot of effort now. Many people are jumping onto it. And well, one thing that was my question that actually I wanted to ask Lorenzo is that, for example, I think it would be great to be able to also to learn what is, for example, an unsafe concept. Also considering, for example, culture and stuff, right? So I don't know if you show images of girls in bikini on the beach, it's perfectly safe for us. Maybe in some other cultures, it's completely unsafe. So you want to kind of make sure that you are able to, or the user can indicate this kind of information. Because otherwise, we are still kind of sticking to stereotypes, right? Some of the things that we say, I don't know, I cannot see blood. Well, fine, but if I'm, I don't know, a surgeon, maybe blood, it's just normal to see, for example. So it's you have to put the context, so also related to what I tell you. So what you said, context is important. What we try to solve here is kind of context-free type of things, which has a limitation, of course, does work because most of the things that we have on internet are kind of context-free, but of course we want to be able to incorporate context because then we give the user more power, more control, and the models are definitely more explainable as well. Yes.
So I have just one question, like how did you come up with the initial prompts that you know that are potentially generating bias content?
Well, I mean, it wasn't us. I mean, these are some standard prompts that are already used by, well, I think in Clip as well, they had them. I think there are some of these prompts. Yes, I mean, that's definitely a good question, especially for the training. Then, of course, in the inference, I mean, you can control that work. There are some standard prompts in which you can do. Okay, thanks a lot. So let's move. Let's move to the next presentation. So Charlotte will tell you a little bit about let's say the human sustainability, and you will see some of the statistics we have about recruiting young talents in ELIAS. And she's in charge of, let's say, of the PhD recruitment in ELIAS.
Okay, should be good now. Okay. So thank you very much, Niku. It's really great to be here talking. So basically, I will be endeavoring today to show you how we can foster scientific excellence in sustainable AI. So basically, we have two ways of doing that. The first one is to develop and equip a network of promising young researchers with advanced skills to become key actors of sustainable AI. This is the work that we do at IP Paris. And the second way is to expand the existing world-class European AI community to build the European lighthouse in AI and sustainability. And this is work that is done by our colleagues at the University of Milan and at the Czech Technical University. So first things first, how to develop a network of promising young researchers. So as Niku mentioned, I'm in charge of a PhD program. So this is what we are doing. We have developed a PhD and postdoc program in sustainable AI that builds on the existing network of excellent ELIAS, so the European Laboratory for Learning and Intelligent Systems. So a few words about this PhD and also postdoc program. So it's mostly for PhD students, but we also welcome postdocs. So the way this is set up is that the PhD student or the postdoc will have a joint supervision. That means a main advisor and a co-advisor, and then the student or postdoc should spend some time at the co-advisor's institution, roughly 6 months or more. And we also encourage cross-domain collaborations. That is to say that the student can have a main advisor in academia or a co-advisor in industry or in a completely different field of research. That is to say, if it's not machine learning or AI, it could be anything ranging from biology to finance to you name it. So the main point of entry through this program is through a yearly competitive call for applications with a 10% acceptance rate. More about that in just a minute. We also offer the PhDs and postdoc some events that are organized by the ELIAS and ELIAS networks. And we also offer them some mobility support. I will also talk about that a bit later on during the presentation. And lastly, for the setup, so the way that the program is constructed is that the student, the PhD student or the postdoc should have a research project that is linked to sustainable AI, industry, or interdisciplinarity in some way. You have some examples here on the slides, for instance, law and ethics, earth and climate science, and tech transfer and entrepreneurship, to name but a few. So this is the call for applications that we currently have. So this is currently ongoing. So I know there's a lot of numbers, so I'm going to give a bit of context beforehand. So about the call, first of all, the way that this is structured is that we act as a matchmaking service. So basically we have advisors that are in dire need of excellent students, and we have students that very much want to pursue a PhD in sustainable AI, and we help the two meet. So I want you to pay close attention to the map that you can see on the side. It's a bit maybe light because of the sun, but we'll explain a bit more about it. So basically, the main thing that you have to know and to see on this map is that we receive applications from all over the world, with a lot of people that are not from Europe, but from outside of it. And this is actually very good. This is exactly what the program is about. What we want is to attract and retain talents in Europe to ensure the competitiveness of Europe in AI research. So on that point, I think we are doing pretty well. And another thing that I wanted to mention, so the program is also very successful, as you can see with these numbers. We've received over 1,400 applications, with 20% of females in the applicant pool, and with some representation from the ELIAS network as well. So a bit more about the events that we offer the students and the postdocs. So we have different categories of events. We have, of course, winter and summer schools. You can see in bold the events that are organized by partners of the ELIAS consortium. We also have the ELIAS Doctoral Symposium, which is the highlight of the PhD and postdoc program. So basically, it's a week-long symposium where the community can meet and catch up and attend several workshops, keynote speeches, poster sessions, and just have a good time overall. And last but not least, we also have some reading groups. At the moment, we have 2 of them, but we have a third one that is coming very soon, and we will, of course, promote it on social media when we have more information. So we also support the community through the ELIAS Mobility Program, which we launched last year. So some words about that as well, some more information. So basically, any PhD or postdoc is eligible to apply. They don't have to be part of ELIAS, but we do ask that the research study that they will conduct is in link with the ELIAS themes, of course, and sustainability as a whole. So basically, the way this is set up, what the kind of visit that would be eligible is a PhD or a postdoc visiting an academic or an industry partner, either in the ELIS or in the ELIAS network. This visit should take place in Europe for a maximum of 6 months in the case of an academic stay, and for a maximum of 3 months in the case of an industry internship. And we offer up to 2,400 euro per researcher per year during the duration of the postdoc or the PhD thesis. So again, some numbers to show you how we doing right now. So the program was launched last year. So this is the number for the year 2024. I think we're doing pretty well at the moment. So we have received some applications that span 9 countries. We have funded 20 PhD students and 2 postdocs at the moment, with 20% of them being people that were outside of the ELIAS network. And you can see also that Central Europe is pretty well represented in terms of mobility, so it's quite good. But our next steps would be, of course, to increase this geographical coverage. You can see that in the north and in Eastern Europe, we have nothing yet, so it would be very good to have some visits taking place there. We also want to encourage cross-domain collaborations. So visits for instance, visit that would be in link with biology or something that is not linked to AI or machine learning directly, or something that has to do with the industry as a whole. And we also want very much to promote postdoc applications because we only have 2 postdocs for the moment, so it's a bit low. So shout out to all the postdocs in the room if you're interested. So that's for the first part. So the second part of the presentation, so how to foster the next generation in sustainable AI. Well, the second way to do that is to expand the existing world-class European AI community. So this part of the work is led by the University of Milan. And basically what they do is that they have designed a fellowship program in sustainable AI that also builds on the existing one in ELIAS. So in practice, what is it that they do? They basically have opened a call for fellows, which are seasoned researchers, and scholars, which are more junior researchers, to join the ELIAS and ELIAS networks at the same time, with the more precise goal of to reinforce and expand the ELIAS and ELIAS networks with scientists working in sustainable AI, but also to promote gender balance, but as well scientific excellence, representation from underrepresented countries such as Eastern Europe, and to develop a transparent and reliable evaluation process. Some numbers about the call that took place last year, so 2024. So we received 240 nominations with an acceptance rate overall of 67%, which is not that bad. So overall, we had 89 new fellows and 72 new scholars. You have the number on the screen on the right, with a gender balance of 29% of females. If we take a closer look at ELIAS in particular, so we had, before this call, 21 scientists that were involved in the ELIAS network. So after this call, we gained 13 new scientists. So in total, 34 fellows and scholars that are involved in the ELIAS network. So some more information about these new fellows and scholars. So the gender balance is 31% of females. These researchers are also involved in research that is in link with AI for a sustainable society. And if we look at the countries of the affiliations of these fellows and scholars, we can see that it spans six countries, with Poland and Greece being represented for the first time in the network. So it works really well for the goal. So it works really well for the goal of championing underrepresented countries in Eastern Europe especially. Okay, so that's it for this part. So for the last one, the expansion of the world-class AI community. So we've seen that with the call for fellows and scholars, it was more at the individual level. For this one, it's more at the institutional level, a work that is led by the CTU, so Czech Technical University. And they aim to create a virtual center of excellence in sustainable and trustworthy AI. So in practice, again, what they do is that they want to onboard new institutions focusing on sustainable AI to the ELIAS and ELIAS network and monitor the growth of these networks. With more specific goals, such as grow an inclusive and interdisciplinary research community based on gender, seniority, discipline, and such. And also to create a synergy with the ELIAS network. And as was the case for the previous part, they also want to focus on scientific excellence, championing representation from underrepresented countries, developing transparent and reliable evaluation process, and to reinforce the virtual center of excellence by supporting local workshop and scientific events. I will talk about that more in a second as well. So for the monitoring of the network, you have here the new institutions that have been onboarded in the last 6 years. So before ELIAS, there was one, the ELIAS Unit Prague in 2019. And since the start of ELIAS, we've had 3 new institutions being onboarded in Eastern Europe, one in Sofia, one in Warsaw, and one in Lviv. And the unit in Warsaw is also involved in ELIAS. And something else that I want to mention is that a new call will be released in the spring for new institution. Okay, and so for the support of scientific workshops and events, you have here some of the events that have been supported by CTU. most recently, a workshop, a journal that was featured in a workshop at the AI Action Summit in Paris last February. And so to conclude this presentation, so fostering the next generation of talent and sustainable AI, okay, but how do we do it? So we do it in several ways. A PhD program for young researchers in an active and excellent community. We also offer mobility support specifically in Europe. We also expand the existing community at the institutional and at the individual level. And most of all, we want to attract and retain talent in Europe. So for our future plans, we want to focus on diversity, gender balance, and interdisciplinarity. Of course, we are already doing that, but we want to do it a bit better, as well as promote underrepresented region and help them join the networks as well. And we also want very much to create a synergy with ELIAS and other networks of excellence. I think we're doing that already with ELIAS, but we would very much like to do that with other networks of excellence as well. And perhaps to some events together, have a mobility support in place for all the networks of excellence. Yeah. Thank you.
Will be very fast. No, so one thing that I already talked to Marius, I think, especially for people in Bucharest, I mean, what I encourage here, I mean, as now with a new AI hub, I think it will be a good opportunity to have an ELIAS unit in Bucharest as well. And I think that will also give you, the young guys, opportunities also to travel a bit more and to be connected more with the ELIAS community at large. I think this is quite important. That would be nice. If you have any questions to her.
Yes.
I might have missed it, but how long do people typically stay when they do travel to other ELIAS units? Is it like a revisit? Do people stay weeks, months? What is the?
Okay, so it really depends. For PhD students, they have a mandatory 6-month visit. So they have to stay at least 6 months, but they can split the visit in for instance, 2 visits of 3 months each. But it's true that it's a lot of resources involved. So usually when people travel, they don't travel for like a few days or like a few weeks. They usually stay at least a month.
So I would say minimum of 3 months. That would be typical. So we do have funds for this. So if you want to come and visit some of the ELIAS partners and so on, just let us know. I mean, we are talking also to people in Bucharest as well.
And I would say even for your research, usually it's best if you stay at least a few months if you want to conduct something productive.
Yeah.
I think so. No more questions? Okay, well.
Okay, so let's move ahead. Now we have complex half an hour at least. What was the schedule and the one I can talk. We talk about now what we are going to talk about is a connection between our community
I took less than 20 minutes.
internship, innovation, and so on. So we have Nina and Isabel here that will tell us a little bit about what.
Okay, can you hear me or should I use the microphone?
It's fine.
Okay, then I'm gonna use the microphone. Okay, hi everyone. My name is Nina Peters, and I'm coordinator at the Tübingen AI Center in Germany. And I'm very happy to be here with you in Bucharest and yeah, able to talk about something that is very relevant nowadays and very important as well. Indeed, and will hopefully also shape the landscape of AI-driven and ML research and European innovation. I'm talking about the, let me see. Here we go. I'm talking about the European Leadership in Innovation with AI and Science Alliance. In short, simply ELIAS Alliance. So the underlying, let's say, mission of the Alliance is actually to ensure that research, groundbreaking research, and brilliant research that is being conducted and happening all over European universities actually comes into being, that they don't just pile up in academic journals, but actually make a real difference in the world. And you ask yourself probably like, how do we do that? How do we easily bring something from the lab to the market? And this is actually where the ELIAS Alliance comes in and helps to support. Indeed. So what is the ELIAS Alliance? The ELIAS Alliance is a pan-European network, and it supports researchers, young talents in their journey, in their startup journey, and their entrepreneurial endeavors. So we try to act as a bridge between academia and the industry, to bring your ideas into reality and make it really happen. So we actually have a few, let's say, support mechanisms in place. So we support by giving access researchers and PhD students access to educational programs as funding, mentorship, but also other trainings, to help them to really navigate through the kind of tricky entrepreneurial and tech transfer world, which is rather new to them, right? Then we also collaborate with industry, and here we help them translate their research into actual products. We connect investors, researchers, and government to accelerate their research into really scalable, scalable spin-offs. Then thirdly, we accelerate already established companies, and here we support companies and accelerate their, and indeed achieve, let's say, or scale their operations and achieve sustainable growth. And lastly, we support startups in general, deep tech startups, because let's face it, academia isn't always the best in supporting and recognizing. And indeed, we want to support. And actually, this also brings me to another objective of the ELIAS Alliance, is to foster value creation literacy in academia. Because most of the time, if a researcher, if a young talent works on a project, this is something that they do in their free time as a hobby. They don't really get the recognition from academia and not the support. And we want to change that. We really want to make this value creation an integral component of academia, academic education, and curriculum. Indeed, but how do we make this happen, let's say on a more local basis? This is where the ELIAS nodes come in. So let me quickly, we have a launch video, which I'm gonna skip now because we have 3 testimonials coming up, and I don't want them to wait longer. They have a busy schedule. So here you can see, oops. Anyhow, doesn't matter. So yeah, the ELIAS nodes are actually lying at the heart of the ELIAS Alliance, and they're essentially AI hubs or innovation hubs spread all across Europe. And for now, we have 8 hubs in Amsterdam, Barcelona, Cambridge, Copenhagen, Munich, Potsdam, Tübingen, and Zurich. And essentially, yeah, they help entrepreneurs, young entrepreneurs in their startup journey. And let's see. Wrong slide, sorry. They help young entrepreneurs in their startup journey. And essentially they're embedded into, let's say, a local ecosystem, entrepreneurial ecosystem, where they also get the support of local organizations and trying to bridge the gap between academia and industry. And this is how they support the young talents and trying to actually create an environment in which AI innovation can really thrive. Indeed, and now I'm really happy to actually hand over the word to 3 of our nodes that I was able to indeed get here for a testimonial. They're going to share some highlights and maybe something that are highlights that are coming next, or their vision. And first of all, I'm having Wieland Brendel joining. He's the co-head of the ELIAS node Tübingen, indeed. So this is in Italian. I'm just starting.
All right, can you hear me?
Yes.
Yes, great. Thanks.
Milan, maybe on the full screen would be great. Yeah, okay. Ah, here we.
Hello. Hey, Nina, can you hear me? There seems to be some confusion.
Not yet, we are.
No, we can't hear you yet, Milan.
I can
you
hear
speak
you.
now?
It seems
The one
okay.
who's online can hear you, I think.
Okay, then maybe I just go on and maybe it's a
another
technical
laptop?
issue.
Because we can't hear you yet. I'm sorry, Milan. No, still not. Can you say something?
Yeah,
No.
Nina,
Ah, the others can hear you in the call. It's just us. Okay,
Yeah.
good.
all right.
Yeah, exactly. Yeah, we're trying to. The volume is up, but we're connecting with another device now.
All right.
It must be the laptop.
Maybe I just say a few words because
Here we
it
go.
seems like the timeline is anyways quite short. So I just want to say a few words. I'm super excited about the whole ELIAS Alliance and especially its focus on value creation. I mean, we are always talking about how AI is transforming the world, our society, our economy. And by, as academic institutions which are running at the forefront of AI, I feel we also have a responsibility of not only building kind of, powerful AI methods, but also ensuring that we actually at the end create value, positive value for our society. And I feel this is kind of at the heart of this whole alliance. And, I think there has been in many different European locations, which are also part of this alliance, there have been lots of local initiatives going forward. So for example, in Tübingen, we've been thinking about this for quite a while. We are talking about we are getting value creation really as a part of the curriculum into our master's program, really trying to make it not just a nice to have add-on, but as an actual integral part of our education for the next generation of students. We're trying to focus also or having a track for innovation-focused PhD programs that are focusing on value creation. And we are working together with Saba Valley and business schools to actually help students to translate their ideas into startups. And then again, also on the more European level, I feel there's a huge potential of pushing jointly initiatives, especially those where AI can really give, or we already know that they can give a huge positive impact in our society. I'm talking about education, for example, which will benefit from AI in very different ways, and where I feel a European collaboration can bring a lot of value. AI for sustainable causes, building European foundation models together, which is also something we've already started together with many European partners. And I think it needs this collaboration. Every node in itself is, too local and too disintegrated. But now by joining forces, by learning from other places, by sharing knowledge, resources, and networks, I think we can really make this work and create value for our society. And that's why I'm really excited to be part of this alliance. And now I think I'm just handing over to the next node.
It's exciting who that is.
Exactly. It will be it's a little mystery.
Yeah.
Where
We cannot hear you anymore, Nina.
Now you can hear me.
You can go.
Thank you. Oh, I don't know if it's me. If you change the slide, maybe it's me. No. Okay, who can hear me? Somebody? Great. Okay. Shall I just start presenting?
Yes, that would be great. Thank you.
Yes, okay. Well, thank you, all of you, to be here, and I'm happy to be here because I would always like to introduce our ELIAS Alliance, our ELIAS node in Copenhagen. And yes, we also have a focus on machine learning in our hub and in AI also in general. But we have our founding partners is very much the Pioneer Center and our own computer science department. So, but we are also, of course, working in this agenda. So if you go to the next slide, Nina.
You have to click.
Yes.
So here we're quite new. So we started here in the fall, and what we have got out of working with in the node is that we have created awareness of the partners. So now we need to create a community where we match the industry and our fellows stemming from the industry and our research partners. In this fall, we posted our first knowledge creation work, which was academic digital entrepreneurial guide. This is a guide to our researchers working within the digital field, because we think that being an entrepreneur within the digital field has some characteristics which differs from other types of domains, and we address this guide especially to them. If you use the link, you don't have to do it now, but after, then you can go in and you can see that it is based on a report. It's a literature review reviewing policies within this area for the last 20 years, and then resulting in recommendations to both the academic researchers, but also the universities that supports them, how to get how to start their own business, how to have an impact on society, and how to create relations to industry. Moreover, I would like to show you that we are having a summer school within this Young Researchers Bootcamp in May. And one of our partners, the Pioneer Center of AI, which is also a part of the ELIAS, they are hosting this summer school. And the topic of this is that they focus on machine learning ops and doing that in an entrepreneurial way. So they try to have the researchers to be more entrepreneurial in their work. And the aim of the summer school this year is to have more startups from the university. So please go in and look. And I think I have to make the link better because it goes into the 23, but I will make sure that it's up to date to our 25th summer school. And at last, I would like you to show attention to that we have under the Danish presidency of the EU is that we will be the host, the Copenhagen University will host an AI and Science conference, which will take place the 3rd and 4th of November. And here there will be a focus on how we can accelerate the use of AI and science to meet the societal challenges. We hope that there will be a lot of commissioners there, because it's also there where they will submit their AI and science strategy. We have a back-to-back activities so you can participate in the Digital Tech Summit just right after this conference. So lots of reasons to come to Copenhagen and visit us. Thank you, Nina. That's all from me.
Thanks a lot, Tine. Okay, now we're moving on to Jess, who is the co-head of the ELIAS Node Cambridge. I'm not sure if Jess is still with us.
Yes, hi everyone.
Yes, amazing. Okay, thank you, Jess. I'm already moving to the next slide.
Brilliant, thank you, and good morning, everybody. So yes, at Cambridge, we're really excited to be joining as a node of the ELIAS Alliance. This is such a timely initiative. So not only are we at a moment where we're seeing growing hype about the potential of AI in science, or growing interest in the type of breakthrough capabilities in science that AI could help deliver. We're also at a moment where there's an increasingly urgent conversation about European technological sovereignty and how we are going to create value from the advances we're seeing in AI technologies. And ELIAS is pointing to a really interesting pathway to deliver that type of public benefit in a way that is shared across communities across Europe. So in Cambridge, we are an ecosystem that is well developed in terms of our innovation capabilities. We're home to over 5,000 knowledge-intensive businesses. We like to say we're the world's highest concentration of academic entrepreneurs. But even in an ecosystem like that, or perhaps especially in an ecosystem like that, where we have a range of established commercialization support mechanisms, it's difficult for innovators in the AI community, in the AI for science community, to find the types of support they would need to translate their ideas from the lab to real world impact. There's a sort of hidden geography of innovation support that remains invisible to many of our talented scientists. The ELIAS node is going to help us bridge that gap. So we're working to create an interface between researchers and the wider innovation ecosystem, with the aim of connecting locally, regionally, and at a European level. So the idea is we want to help sciencepreneurs connect with our local innovation and investment networks and business accelerators. We want to help researchers and students to connect to training opportunities in how to use AI in their science or how to commercialize their ideas. And we want to help build bridges across Europe through the Alliance. What does that look like in practice? Well, we are trying to create opportunities for training and mentorship that can help scientists learn how to use AI in their research and how to take those ideas out into the real world. We have an established program called Accelerate Science, which has trained over 1,500 researchers across 85 university departments in core skills in data science and AI. And we're using our experience with the ELIAS node to expand that training so that we can start bringing in entrepreneurial skills to our training offer. Secondly, we want to help connect networks across academia, startups, venture capital, and business through meetups, collaborative workshops on open innovation challenges, or training sessions and mentoring sessions. And then we also want to be bringing a focus on responsible innovation to the Cambridge AI ecosystem, so that as we're developing these new AI applications, we're really taking care to center social benefit and bring the voices of different effective communities or stakeholders to the table. We're figuring out how to do this at the moment, building on both the public dialogue and engagement activities we have going on locally, but also learning from our partners and collaborators across Alliance, which is a real strength of this initiative, that we can all see what's working in different places and figure out how to adapt it to our local contexts. So just thank you to Nina and Matthias and colleagues in ELIAS for pulling the Alliance together, and we're really looking forward to working with you.
Thanks so much, Jess. Thanks to the three of you, by the way, for joining. And okay, then you can all hear me still online and also all good? Okay, perfect. Then I'm very quickly just going to talk about some of the initiatives that we have started, the pan-European ones. So first of all, as mentioned also yesterday, we are starting a startup internship program. This is actually for researchers to gain some insight into how a startup really works. And indeed, so they're able to apply their research in a more practical and more real world setting. And this is a great alternative to the internships that you have with the normal ones, at the big companies, Amazon and Google. But like this, researchers do this kind of internship, they really get to know the ups and downs, ins and outs, and opportunities and challenges that come with running and starting a startup. Indeed, then next we have the Transformative Technology Summer School. And here, essentially, young talents are learning how to commercialize, about the commercialization process, let's say. And secondly, very important here is also empowerment, to give researchers the confidence of actually going out there and bringing their idea to life. So showing them another path than academia, actually. Thirdly, we have the innovation challenges, the idea hack, which is organized by Ideas, and also other competitions. And this is to bring everyone together, entrepreneurs, startups, and professionals from the industry to really work on real world, let's say, problems and find a solution. This is also a great platform to collaborate and for researchers to really test their ideas and really develop new solutions. And lastly, we have the AI Launchpad, the Pan-European Accelerator Program, but here I'm going to hand over to Isabel, who's going to tell us a bit more about this one. Thank you very much.
Thank you, Nina. Okay, Nina and I are getting the hardest job of the day, running an overtime workshop with some important topics. So I'm from the ETH Zurich. We're also part of the consortium, and a lot of people asked me yesterday evening because they thought we were part of it because we always talk about the financing. So Switzerland is also part of this consortium, and we find it very important that we actually scale tech startups within Europe. Now, why is that important? The recent geopolitical problems that we see in our world make it very evident. Not just that do we have to arm Europe up, we also have to use the technical talent we have within Europe, because we're not lacking it at all. I mean, most of you are fantastic scientists. Now, who of you has ever thought about building a business? Raise your hands. Okay. Has any of you done it? Okay, great. So we have one person in the room, and I think what you have to know when you're going down the entrepreneurial route, I'm an entrepreneur myself, it is doable and you have to just find the path. So thank you to Nina and the group for setting up the path. Use the support that is there, because sometimes you're going to have questions and you're going to be in a very odd field. Who of you has a technical background? Everyone. So for those of you that think business is hard, it isn't, okay? But one core thing is, even if you're a fantastic programmer, the market doesn't care about your programming skills, right? What they care about is the use case and the way that you're going to offer it. Okay, so as an entrepreneurial facilitator, we focus a lot on commercialization, also at ETH Zurich. We have fantastic tech talent, they have fantastic ideas, but they often lack the use cases that the market want, or they're not communicating it properly. So when we look at how can you facilitate, I'm just going to fast forward, entrepreneurship systematically at a university, I'm going to ask for raise of hands on who are the professors in the room. Who are the professors? Okay, you're gatekeepers to innovation, okay? Because either you can push your pupils to bring their science to market, or you can block them. So in Zurich, we set up something that is called a Dandelion Award for the professors. That means we give them also visibility that they're doing a good job of pushing science to market. And they're actually really the gatekeepers of a lot of good science that can go to market. So if you see somebody that is sitting on a commercialization topic, you should either give that person the support to go down that route, or if the person doesn't want to become an entrepreneur, that is totally fine. Find maybe somebody else that could join this person and bring it to market. So that's why we have the award system set up very early. The other thing that is crucial is that when people enter university, 60% of our pupils say, hey, I would imagine becoming an entrepreneur, right? That's at the enter of the bachelor studies. At the master's level, they're like, no way, Jose, like 20% is still clicking yes. Okay, why? We think it's about opportunity cost, okay? You get very starved as a PhD and postdoc as well on your salary. So when you hit that point of sitting on a really good commercializational topic,
you kind of like, I'm going to Google. No, I'm going somewhere else, bye-bye. So we really have to work also there with all our university courses that we build in this mindset that they can commercialize their science, okay? Most of us have universities courses. I heard there's a hackathon this weekend here. Were you aware of it? It's in the library. Yeah, it's an innovation hackathon right here this weekend. And hackathons are a fantastic way for you to take care of two things. You don't want to be alone on your entrepreneurial journey, so you want to find a team, and hackathons give you this. And often at hackathons, you have actually a problem from the real world, from the industry that they bring that you can work on. So join these kind of like formats to foster this. Nina talked about the summer schools that we're running, and we're running them across Europe to give you just a sneak peek how to hack through your idea into the making it an actual business within a week. Okay, now fast forward, why do we actually think as well that team building is important? A lot of you do not have a team, and we see that the breakout rate in entrepreneurship is very high if you remain standalone. So if you're interested to run a team building program at your university, we have in the notes the Talent Kick program. We have everything videoed and documented how you can do that. This program really emphasizes team building and front and center. Last but not least, I'm going to talk about the Launchpad. Now, why do we think it was important that we use existing accelerators as a step into the door, but then let other startups travel across Europe with the AI Launchpad? So basically, AI Launchpad is like an exchange program for startups. Why is this important? We want to keep tech talent and really scale-ups within Europe, because we lose a lot of them to the US market. But actually, we have 5 million people that you can cater within Europe. That makes it very lucrative for you also to stay here. But we have to actually, on a regulation base, lower the market entry barriers and also help startups like cater, for example, the Romanian market or cater the German market. So if you're a startup and you're a bit further along, this is what we basically put into place. We've onboarded some universities already, and we have 10 startups that this week and next week are in different European hubs across Europe, actually getting to know the local markets. We're going to have a next call that is now going to be open for the deadline of the 31st of July, where you can apply that you get accelerated and then enter another market in March next year. Now, we've partnered with non-ELIAS universities. Now, everybody's going to ask me why. We said we had to strengthen our networks with other universities. So in a first take, we were hyper-focused on working with the best startup ecosystems in Europe. Maybe you know, but Unternehmertum has like all the money of BMW to do entrepreneurship, so they have fantastic programs in place. That's why we wanted to have access for our ELIAS members to their programs. Then we have KTH University in Sweden that is part of it, and Vienna's University and DTU in Copenhagen, and Campus Founders in Melbourne, and ourselves. Now, in the next batch, all the nodes will be onboarded as well, so in summer you can get access even to more universities. For those universities that want to join, please reach out to me after this talk. Now, that's it from our side, and I wish you all a lot of success on your academic and entrepreneurial journeys.
Breakfast.